Beloved learners, names of topics with exact duration is mentioned in the description box. On desktop and laptop, description box is just below the channel name. On smartphones, description box is just above the channel name. Above channel name, you can see views and uploading time, and just beside uploading time you can see some dots and more, like this red more. Okay, there will be dots and more written. Please tap or click on the word more and you will find details of the video. If you want to get any maths question of IGCSE O and A level solved, please send me the question number and paper code through WhatsApp. I will do the needful. My WhatsApp number is 880 1711 319 456. Thank you all. So let's move on to the topics of probability and statistics 1. Now we are going to solve some question under mean, variance and standard deviation topic. And under this topic we have chosen the first question from paper 9709/51 for the session May June 25, and question number 3 belongs to the mentioned topic. And part A and B of this question don't belong to our discussable topic. That's why let's see question number 3C. 3C says two other teams of runners, the Eagles and the Swifts, also took part in the event. The recorded times in seconds for 20 runners from the Eagles and 30 runners from the Swifts are denoted by X and Y respectively. So runner indicates runners of Eagles are denoted by X and runners of Swifts are denoted by Y. It is given that sum of X is equal to 175 and that the mean of Y is 8.4. So two information has been given and we will have to find the mean time of all 50 runners. So total time taken by, first of all let us write total time taken by first team was Eagles. Taken by Eagles is denoted by X equal to, so as this is total time, so it will be sum of X. Okay, sum of X equal to, what is the total time taken by the Eagles is given 175 seconds or minute, whatever. 175, it is given sum of X is equal to 175. Whether minute or second, the unit has not been mentioned, so let us write only 175 seconds. Okay, then total time taken by the Swifts, time taken by the Swifts. So for Swifts means Y, the total time has not been given. Look at this, it is mean time has been given, and if we want to find the mean time we will have to multiply by 30, because how many Swifts, how many Swifts are there? 30 runners from the Swift. Look at this, 20 Eagles, 20 was Eagles, number of runners in 20 was number of runners in Eagle was 20, and number of runners in Swift was 30. So mean time is given, it is not total, we will have to find. Look at this, this is the mean time. So if we want to find the total time, then we will have to multiply by total number. So it is 8.4 into 8.4 into 30. 8.4 into 30 runners. 30 runners. So finally it is going to be, if we multiply 30 by 8.4, it is 252 seconds or minute, whatever you tell. We are supposing it to be in seconds. Okay, now we are going to find the mean of all 50 runners. Okay, now we can write mean is equal to sum of x, that means sum of all the runner time taken by all eagles as well as sum of the all times, that means total time taken by swifts, which is sum of y, over total number of runners is 50. 30 plus 20, it is 50. We may write here n. So if we substitute the values, what is it going to be? 175 plus 252, which will be divided by total number of runners, which is 50. So finally our mean value is going to be, using our calculator, we find that mean time of all 50 runners is 8.54 seconds. 8.54 seconds. Okay, seconds or minutes, you may use any unit, or you can write only units. Let's see the next question. The next question says it is given that sum of x squared is 1823. It is also known that the standard deviation of the time taken by all 50 runners is 1.38. So standard deviation is given. Okay, let us start with standard deviation. Let us write standard deviation. So standard deviation is given. Standard deviation. Standard deviation is 1.38. So formula for standard deviation is square root over variance. Okay, so square root over, it is square root over variance. And what is the variance? Variance is sum of x squared plus sum of y squared over total number. Total number is n, and our standard deviation is given 1.38. After that, if we substitute the values, it is going to be n means 50. We know total number of runners is 50. So let us write 50, and sum of x square is given 1823. 1823. Sum of y square is to be obtained. Okay, so we will just leave it unchanged. Unchanged is sum of y square equal to, sorry, I made a mistake in writing the formula. Formula is sum of fx square plus fy square over n minus, we will have to subtract the mean value, square of mean value. Okay, square of mean value, and then our right side is 1.38. Well, now minus mean value, already we have found our mean. Let us see how much was our mean. Our mean value was 175 over 252 over 50. That means if we add up, it is going to be 427 over 50. 427 over 50, then whole squared. Whole squared is equal to, and if we remove the square root from left to right, then it is going to be 1.38 square. So 1.38 square is 1.9044. 1.9044. Well, then if we substitute the value, if we take this value to the right side, it is going to be 1823 plus sum of y squared over 50. If we transpose this to the right side, it will be definitely addition. Then we will have to get, it is using our calculator, we get 427 over 50 whole square plus 1.9044 equal to 74.836. 74.836. Well, now by doing cross multiplication, we can see that our 123, that is sum of y square, is going to be 50 into 74.836. Then from left side 1823 will be subtracted. 1823. If we do so, then our sum of y square is going to be, let us use our calculator. It is 50 into 74.836 minus 1823 equal to 1918.8. 1918.8. Okay. So this is what the standard deviation of the given data is. So this is all about the solution to the part C and D of question number 3 of paper 51. Let's see the next question. The next question has been selected from paper 9709/52 for the session May June 25, and we are solving question number 5 under the same topic. The times taken T minutes by 300 students to travel to Hollowtown College are recorded. The results are summarized in the table below. Less than 10 seconds, that means 0 until less than 10 seconds, or 10 less than 20 seconds, 30 seconds, and cumulative frequencies have been given. Okay. Now we will have to find out the midpoints of each of the classes. Okay. So first midpoint is, this is 5. Okay. And then the next midpoint will be from 10 until 20, it is 15. Then 20 until 30, it is going to be 25. And then 30 until 40, it is going to be 35. Then 40 until 60, it is 50. And 60 until 90, it is 75. So our midpoints are 75. Okay. 5, 15, 25, 35, 50 and 75. Now we'll have to find frequencies. They have given the cumulative frequency. So first frequency is 34. Second one, from 84, if we subtract 34, it is going to be 52. Third frequency is from 142, if we subtract 52, it is going to be, sorry, if we subtract 86, it is going to be 56. So 34, 52, 56. Then from 208, if we subtract 142, it is 66. Then from 265, if we subtract 8, then it is 57. Then from 300, if we subtract 65, it is 35. So these are the frequencies as well as midpoints of each of the classes. Now question number A is about frequency graphs, so we are not going to solve that one. We are going to find our mean. So let's see which question is talking about mean. Question number C says, calculate estimates of the mean and standard deviation of the times taken to travel to college by 300 students. So all of the points, we have already find the points. So midpoints. First, let us write the midpoints. Midpoints are, what were the midpoints we have already seen? It is 5, 5, 15, 25, 15, 25, 35, 50 and 75. 35, 50 as well as 75. 50 as well as 75. And then the frequencies are, let us find the frequencies. Frequencies are frequencies are, what are the frequencies we have seen? 34, 52, 56. 34, 52, then 56, 56, 66, 57, 66, 57, and finally 35 are the midpoints, I mean frequencies. So now easily we can find the mean. They have told us to find, estimate the mean. So mean is equal to, hence our mean, what is the formula for mean? The midpoint into frequency. The formula for mean is what? Midpoint into frequency. So 5 into 34, 5 into 34. Or if I write the formula, I think it's not necessary for you to write the formula, because since grade 8 or 9 you have been continuing finding means, so it is unnecessary to be written the formula. We are just writing directly. So 15 into 52, 15 into 52 plus 25 into 56, 56 plus 35 into 66, 66 plus 50 into 57, 50 into 57, 50 into 57 plus 75 into 35 over, there are total 300 students, over 300. Using our calculator, we see that our mean value is, using our calculator we will find 5 into 34 plus 15 into 52 plus 25 into 56 plus 35 into 66. 35 into 66, not 56, it is 66. It is 66. 35 into 66 plus 15 to 57 plus 75 into 35 equal to 33.8 minutes. 33.8 minutes. So our mean value is 33.8 minutes. Well, and I think this direct answer should not be written. Let me write in fraction first. For more accurate answer, let us leave it first in simplest form, which is 1013. That is, numerator is going to be 10135 over, in common fraction let us leave this 300. Then finally we can write our mean value is 33.8 minutes. 33.8 minutes. Because if we require this information later on, we will have to write the exact value. Then the second one is, we are going to find the standard deviation. Standard deviation, so SD is equal to, we know standard deviation is equal to standard deviation The formula is known to as standard deviation is equal to f square x square, that means f into x squared. Again, I am not writing the formula, please don't get confused. Or if I write the formula, it will be formula is Sd equal to sum of fi x squared over n minus mean value, mean means mu, okay, mu whole square, and all of them will be under square root. That means it is that means standard deviation is the fi x square fi into x square minus mu square means mean square. That is, this is actually square root of variance. The formula of variance is sum of fi x square over n minus mean value square of the mean value. So we are just doing so. So all the midpoints will be squared. Okay. If we square the midpoints, it is going to be 5 square into 34. So let us write 5 square into 34. 5 square into 34 plus 15 square into 52. 15 square into 52 plus 25 square. 25 square in 75 square into 35 over n. N is our total number of data is 300. Then minus, we will have to do subtraction, minus mean square. Our mean is 101 over 35 divided by, let me write mean, though space is very narrow, let it be written. So we have inserted all the information that standard deviation is the square root of variance. So what was our variance? Variance was sum of f square x squared, not fx square, fx squared means x squared into f, each of the midpoint square into our frequency, individual frequency. Then sum of that is going to be our variance, and from that we will have to subtract mean value, square of mean value. So using our calculator, we find that our standard deviation is going to be square root over 5 square into 34 plus 15 square into 25 plus 25 square into 56 plus 35 square into 66 plus 50 square into 57 plus 75 square into 35 minus 10135 over 300 whole square equal to 20.4 minutes is the standard deviation of this data. Well, it is not exceptional at all. It's as same as the previous one. Let's see the next question under this topic. The next question has been selected from paper 9709/53 for the session May 25, and where we are going to solve the first question under the same topic. For a set of 40 values of x, it is found that sum of x minus k is 836 and sum of x minus k whole square is equal to 25410.8, where k is a constant. First question says, given that the mean of these 40 values is 124, find the value of k. So we should not forget that this is a coding data. It's a coding data. It's coding data. Okay. So for coding data, how will we solve this? We will first write, it's given that sum of x minus k is given how much? 836. So it is actually sum of x minus total how many values there are there, how many x's are there? 40. So it is going to be 40k. 40k is equal to 836. Now if we simplify more, our sum of x is going to be sum of. So what is our sum of x? Sum of x is actually total value of all of these 40 numbers. So total values are, mean is 124, total number is 40. So total value of x is going to be 40 into 124 minus 40k is equal to 836. Hence our k is going to be, if we simplify and isolate k, our k is, hence our k is going to be 834, that is 4 into 124, that is 496. 496 minus 836 over 40. Hence our value of k is going to be 103.1. 103.1. So this is the value of our k. So in coding data, remember, sum of x minus k means actually sum of x minus 40k. Sum of k means actually 40. There are total values, total number of data is 40. So it will be multiplied by 40. And sum of x means actually total values, not mean value. Remember, sum of x is not mean value. This is the total value. That's why we have multiplied the mean value by total numbers. Then let's see what B says. The question number B says, find the standard deviation of these 40 values of x. Remember, standard deviation and variance is not affected by coding data. So coding data doesn't affect. Let us write coding data. For mean, coding data is applicable, but for standard deviation variance, coding data doesn't affect it. Coding data doesn't affect standard deviation or variance. Standard deviation or variance. Well, so the simple formula we are going to apply for finding standard deviation. What is that formula? Our formula is standard deviation is equal to, as we did in the previous case, square root under that sum of x minus k whole squared over total number of data. Total number of data is minus mean whole square. So mean is actually, we know, sum of x minus k, sum of x minus k, or k can be substituted as 40. No, okay, a value is given, but we are going to use the exact values whole square. Well, hence our standard deviation is going to be, if we substitute the values, what is it going to be? Let us substitute equal to x minus k whole square is given. X minus k whole square is equal to what? This is x minus k whole square. X minus k square is 254108. Okay, and total number is 40. Already we have found this. So it is 25410. 25410.8 over 40 minus our x minus k over 9 is also given. We have used x minus k is 836. So it is 836 over 40. 836 over 40 whole squared. So finally our standard deviation is going to be, using our calculator, we get 14.1. 14.1. So what have we learned from this question? That for mean value we will have to consider coding data, but for standard deviation and variance the coding data doesn't affect this. That's why simply we apply the formula. Let's see the next question. The next question has been selected from paper 9709/55 for the session May June 25, and we are going to solve the first question, which says two fair six-sided dice with faces labeled 1, 2, 3, 4, 5 and 6 are thrown. The two scores are noted. The random variable x is defined as follows. If two scores are equal, then x is equal to 0. If two scores are not equal, x is the larger score minus the smaller score. That means it's subtraction between or difference between the two scores. Draw up the probability distribution table for x, which has been solved under the topic probability distribution table. Let's see question number B. Question number B is at the bottom of this page. Yes, find the find ex. Ex means actually mean, okay, and variance of x. So let us find ex. Formula of ex, we know x is equal to sum of fixi over n. As it is probability given, so sum of x into probability of individual one will be multiplied by this over total number of participant or total number of outcomes. So total number of outcome is 36, because if two dice are thrown together, so 6 sixes are 36. Now from the probability distribution table we will find the product of each of the probability and x values. This is our probability distribution table. When x is 0, then our probability is 1 over 6. When x is 1, so let us substitute the values. First one is 0 into 6, 0 into 6 plus. Second one is 1 into 5 over 18, 1 into 0 into 1 over 6. Sorry, in the formula I made a mistake. It should not be divided by n, because already we are multiplying by the probability, so there should be no n. So it is simply multiplication of x value as well as probability, each probability. So first one is going to be 0. If we multiply, it is going to be 0. And second one is 1 into 10. So 10 over 36. 10 over 36. And the second one is 2 into 8. So 16 over 36. 16 over 36. Plus 3 into 6. 18 over 36. Plus 4 fours are 16, 16 over 36 as well as 10 over 36. 10 over 36. So if we use our calculator, we will see this is 10, 26 plus 18, so 44, 60, 70. It is 70 over 36. If we divide 70 by 36, it is going to be 1.94. So our mean value is 1.94. Now we will find the standard deviation, and you know the formula for standard deviation is also same. Standard deviation is equal to, sorry, not standard, variance. They have told us to find the variance. So variance is equal to variance of x. You know the formula is x squared sum of x squared into each of the probability. Okay, so we, instead of x, just we will make square. If we do so, what will it be? The first one is 0 as usual. First one is 0, and second one is going to be 1 square, so it is 10, again 10 over 36. 10 over 36. Then the third one is going to be plus 8 is 2 square. Okay, so 2 square 4, 32 over 36, 32 over 36, 36. Then fourth one is going to be 3 square 9, 9 sixes are 54, so 54 over 36. Then fifth one is going to be 4 4 16, so it is 64, 64 over 36. And final one is 5 fives are 5 square means 25, so 50 over 36. Next one is 50 over 36. If we use our calculator to simplify this, 10 over 36 plus 32 over 36, then 9 over 54 over 36 plus 64 over 36, 54 over 36 plus 64 over 36 plus 50 over 36, then minus our mean value. But where is the space to write our mean value? So let me rewrite this. Now it can be shown. So there are total 6 values, 1 2 3 4 5 6. That is x square into probability of each one has been multiplied with x squared, then mean square has been subtracted. So using our calculator we find that our variance is 2.05 is the variance. So that's all about this question. This is from the paper 55. So that is the last of all questions of under this topic. So with this one we are ending this topic. Bismillahir Rahmanir Rahim. So let's move on to the first of all topics of today's discussion. The first topic has been selected as cumulative frequency graph, and under this topic the first question has been chosen from paper 9709/52 for the session May June 25, and question number 5 is going to be solved under this topic. It says the times taken 2 minutes by 300 students to travel to Holloton College are recorded. The results are summarized in the table below. Time is given less than until 10 seconds, 10 minutes, 20 minutes, 30 minutes, 40 minutes, 60 minutes, 90 minutes. Well, so we know how to draw a cumulative frequency graph. This is one of the easiest and most common topics to us. But the mistake we usually make is we always think of the upper bound. But that is true, definitely true. Always we will look at the upper bound of each of the classes. So here upper bounds are 10, 34, 20, 86, 42, 8, 62, 65, then 90 and 300. Now the mistake we make is actually we forget about the first point, the beginning point. The beginning point should be the lowest class, I mean lower bound of the first class. So what is the lower bound here? It is written until 10 seconds. So what may be the, maybe the lower bound of this class, it will be 0. So this is a mistake, and the number of students who took 0 minutes is also 0. That means 0 is also a point. So this point is not considered by many of the students. So please be careful about this. Always we will choose the upper bound, it's correct, but the first point, the initial point or beginning point must be the lower bound of the first class. So what are our points? We have our points are 0 0 10 34 20 86 31 42 42 8 62 65 and 90 300. Let us plot all of these points. So this is the graph of the given information. The graph may not look like an exact graph, but it will look somewhat similar to this if you draw the graph. So please be careful of plotting the points accurately. In the horizontal axis, I mean x-axis, along x-axis we have written the time, and along vertical or y axis we have written the cumulative frequency. Well, and there are 7 points we have marked. We have plotted 7 points: 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7. Now let's see what question number B says. Question number B says that 120 students take more than k minutes to travel to college. Use your graph to estimate the value of k. So here there is a common concept where we make mistake. Actually, 120 students took more than k minutes. So it is actually upper side of the graph. So if 120 students go away from 300, there will be 300 minus 120 students equal to 180 students. So actually we will have to find the point which coincides when the number of student is 180. So please don't get confused. In some cases students find 120. No, it is not 120. They told 120 student took more than that time. So upper part of the graph, let me show from the graph. So the students who took more time are lying above, that means upper part of the graph. So we have seen that it was 120 students. Okay, so 120 is closer to here, as this is 150 120, so somewhat over here. Okay, then if we find the time taken by 120 students, I mean k value of k, it is going to be 35. It is the points might not be coincided exactly, but it will be 35 or 34, so you can write 35. Once again I am clarifying that why did I choose 180. Actually, because the question told that more than 120 students, I mean 120 students took more than this time. Okay, so who took more than this portion? This portion of the graph is for the students who took more time. That means we will have to count from in descending order from top to bottom. Remember, here 120, so 120 student is over here 120. Remember, that means we require to find when, if we count from top to bottom, I mean bottom to top in ascending order, so we will have to count 180. Here it is 120 from top. Let me write here 120. Then from bottom it is actually 180. So this is how you will calculate. So please don't get confused. If you find that 120 from bottom, then it will be wrong, because they have told these 120 students took more time. So more time is always upper part. So less time, that means the time less than k minutes has been taken by 180 students, as the less time has been represented through the lower part of the graph. I think you got my points. Let's see the next question. So answer to the question number B will be 35 students. 35, or you can write even 34 students also. Both of them are acceptable equally. Well, the next question belongs to paper 53. The next question has been selected from paper 9709/53 for the session May June 25, and question number 4 belongs to cumulative frequency graph. It says 84 people attempt a particular puzzle. The times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. And question number A says use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. So 4 minutes to until 7.5 minutes. 4 minutes is over here. If we plot the points, 4 minutes is over here, and 7.5 minutes will be over here. So the number of students who took 4 minutes, it may be, let it be 27. Okay, here let it be 27. And the number of students who took less than 7.5 minutes, it will be 60, I mean 70. So what is the number of students who took between the time between 4 and 7.5 seconds? It will be actually 43. Okay, so number of student is going to be 43. We can write that 43 students took the time between 4 and 7.5 minutes. So 43 students, 43, or it may be 44 also. You can write, there may be a little change in the calculation, so it may be 43 or 44, both of them are equally accepted. So that's all about our first topic, cumulative frequency graph. Let's move on to the next topic. Well, now we are moving on to the next topic, probability distribution table. And the first question has been selected from paper 9709/51 for the session May June 25. And the question we are going to solve is question number 6 of this paper. It says a bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The clue word of the question is without replacement. The random variable x denotes the number of blue marbles selected. Show that x is equal, probability of x equal to 2 is equal to 3 over 7. That means 4 marbles have been selected one after the other, and we will have to find the probability that 2 marbles are blue. So let's start our solution. First of all, we will write our possible probabilities, possible outcomes. So probability when there are x equal to 2 means there are 2 blue marbles picked up. Let's see what are the possible cases. Suppose the first one was blue. We require 2 blue marbles. So blue, blue, and second 2 are red. This is one of the cases. Then let's suppose the first one is blue, second one is red. First one is blue, second one is red, third one is again blue, and final one is red. Or the third case may be first one is red, then the next two are blue. First one is red, then second two are blue, and final one is again red. Or there may be first one is red, second one is blue, red, then blue, again red and blue. This is the fourth case. Now fifth case is it may be first two are red. Suppose first two are red, so surely final two are blue. This is the fifth case. Then sixth case it may be, or first one is blue and final one is also blue. That means there will be 2 red marbles picked in between 2 blues. So these are the total 6 possible cases. Well, now let's write the probability. If the first one is blue, there are total 6 blue marbles out of 10. So it is going to be 6 out of 10 for the first one. Okay. Well, now if second one is also blue, first one is blue, second is also blue, let me mark by this, second one is also blue. So as there is no replacement, so one marble has been decreased from each of this. So it is going to be 5 over 9 into the third one is red. This one is red. So if there is one red marble picked, then there will be 4 out of there remains only 8 marbles left, because every time one marble is decreased. Then final one is also red. So for red, as one red marble has gone away, so there remains only 3 red marble out of total 7 marbles. Now the question is, what about the rest of the cases? In rest of the cases, if we observe, every time actually the probability is same. Why? Because as there is no there is no replacement, so every time a particular color is decreased. So simply all the rest of the cases are similar to the first case. That means there are 6 such cases. So we will have to multiply by 6. I think you have understood. Look, every time if one blue is taken away, the number of blue marble is decreased, as well as the total number of marbles is also decreased. So the cases are all the way same to each other. Hence, if we find our, so our probability is going to be, final probability, if we calculate, it is going to be 7 over, I mean 3 over 7. 3 over 7 shown. Showed. We have shown. They have told us to show that probability of picking up 2 marbles out of 2 blue marbles out of 4 is 3 over 7, and we did so. Next one is probability distribution table. Okay, so for probability distribution table, out of 4 there may be no blue marbles picked, or only 1 blue marbles, 2 blue marbles, or 3 blue marbles, or 4 blue marbles. So let us write the possible cases first. Suppose there is no blue marbles at all. That means probability of x equal to 0 means no blue marbles. That means all 4 are red. Okay. So all 4 are red means probability of red, red, red as well as red. That means if first one is red, there are 4 red marbles. So probability of the first one is 4 over 10. Now as already one marble has been taken away without replacement, so both the total number as well as number of red marble has decreased by 1. So it is 3, then it is 2, it is 1, and every time the total number is also decreased by 1. So 8 and 7. So finally our probability is going to be, when there is no blue marble, it is 24 over 5040, means 1 over 210. 1 over 210. This is one of the cases. Then when there is only one blue marbles picked out of 4, x is equal to 1. So what are the possible cases? It may be first one is blue. First one is blue, rest 3 are red. Okay. Or second one is blue, rest remaining 3 are red. Second one is blue and rest 3 are red. Or there may be the third one is blue. So first 2 are red, third one is blue, and fourth one is also red. Or there may be final one is blue, first 3 are red. So red, 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 and final one is blue. Okay, so our probability is going to be equal to, first one is blue, so total number of blue marble is 6. So 6 over 10, and second all rest 3 are red. Okay, so every time it is decreased by 1, 9, 8 and 7. For first blue it is 4. For second blue, number of blue marble will be 3. For the third one it will be 2. That is 6, 4, 3, 2. Now, as I have already explained, that all the probabilities are, all the possible cases are producing same probability, because there is no replacement. Every time one particular color is decreased, at the same time total number of marbles is also decreased by 1. So how many such cases are there? 1, 2, 3, 4. 4 cases. It will be multiplied by 4. So our probability is going to be, if we use our calculator, it is going to be 4 over 35. 4 over 35. Now next possible case, there may be two blue marbles which has already been obtained. We have already found the probability of picking two blue marble is this. In question number A we have already solved, so it is 3 over 7. 3 over 7. Then if there are 3 blue marbles, what are the cases? Suppose first 3 are red, I mean blue. First 3 are blue, that means final one is red. Or first 2 are blue, first 2 are blue, then third one is red, fourth one is again blue. This is the second possible case. Or second one is red, rest of them are blue. So this is the third possible case. Or only first one is red, and remaining 3, all the remaining 3 are blue. Blue as well as blue. So what are the probability? Probability is going to be, first one is blue, that means 6 over 10. 6 over 10, 6 over 10, then 5 over 9, 5 over 9, then 4 over 8, 4 over 8, then the final one is blue, red. So there are 4 red marbles and total number is 7. And how many such possible cases are there when there are 3 red marbles? There are 4 possible cases. So we will multiply by 4. Multiply by 4. So finally our probability is going to be, so it is 8 over 21. 8 over 21. So 8 over 21 is the probability when there are 3 blue marbles. Then the final case, there may be 4 blue marbles. So let us write probability of when there are 4 blue marbles, x equal to 4. So x equal to 4 is actually first all of them are blue. So probability of blue, again blue and blue. So what is it going to be? First one is 6 over 10, then 5 over 9, 4 over 8 and 3 over 7. So final probability is going to be 1 over 14. 1 over 14. Now we have got all the probability, then let us write them in table. So this is our table. Now we are going to substitute insert the values. When x is equal to 0, there are total 5 values. So let us see what were the values. The first probability when there was no blue marble was, first probability was 1 over 210. Second one was when there was only one blue marble, there were 4 over 35. Third one was 3 over 7. Then fourth probability was 8 over 21, and final one is 1 over 14. So let us substitute them. First one is 1 over, when x is 0, then probability is 1 over 1 or 2 or 10. So first one is 1 over 10, 1 over 210, 210 we are living in simplest fraction. Then the second one is 4 over 35, 4 over 35. Then when there were two blue marbles, it was 3 over 7, 3 over 7. When there were three blue marbles, it was 8 over 21. Then when there were four blue marbles, it was 1 over 40. When there are four blue marbles picked, the probability was 1 over 40. And there is no more. There cannot be more than four blue marbles because only four marbles were picked up in total. So that is what the probability distribution table of this question. Let's see the next question. The next question has been chosen from paper 52, which says, this is the first question of the paper 52. It says Rachel has 3 coins. The first coin is biased so that the probability of obtaining a head when it is thrown is 1/3. The second coin is also biased so that the probability of obtaining a head when it is thrown is 1/4. The third coin is fair. Rachel throws the 3 coins at the same time. The random variable x is the number of tails that she obtains. It is all about tails. Draw up the probability distribution table for x. Let me erase this unnecessary writing. Let us write the individual probability of each of the coins. For the, if there is h obtained, the probabilities are 1/3, 1/4, 1/3 for the first coin. For the second coin, it is 1/4, and for the third coin, it is fair, so it will be half. Okay, 1/3, 1/4, and half. Then for obtaining tail individually, it is 2/3 for the first coin, then 3/4 for the second coin, and since the third one is fair, so it is half. Well, now she has thrown all 3 coins together, and they have told us to find that number of tails. Okay, draw up the probability distribution table. So after throwing this, there may be no tails. Suppose there is no tails, that means all of them are what? Head. So first one is head, second one is also head, third one is also head. So what will it the probability be? The all heads, 1/3 into 1/4 into half, 1/3 into 1/4 into half. So finally our probability of obtaining no head, no tail, is 1 over 24. 1 over 24, first one. Now if he obtains only one tail out of 3, so what are the possibility? Let's see. First one is tail. Okay, first one is tail, second and third are head. Or second one is tail, second one is tail, so first and third one is head. Second one is tail, and first and last one is head. or he might obtain the final one is tail and first two are head. So first two are head and final one is tail. So these are the three possible cases for obtaining one head. So if the first one is tail, it is 2 over 3 probability. Then rest two are head. So 1 over 4 as well as 1 over 2. If first one is head, then the probability is 1/3, and for the second tail it is 3 over 4, and for the final head it is half. Well, if the first two are heads, then it is going to be 1/3 into 1/4, and final one is pair, so it is going to be half. So finally our probability is going to be, denominator is 24 in each case. So this is 2, 2, 3, 5, 5 over 6. 6 over 24 means 1 over 4. Let me write just beside this. Equal to 1 over 4. Then the third possible case is he might obtain two tails. He might obtain two tails. If two tails are obtained, what are the possible cases? Suppose first two are tail. Okay, first two are tail, third one is head. Or first one is tail, second one is head, and third one is also tail. Third one is tail. Or first one is head and last two are tail. So these are the possible three cases when there are two tails. So let us write the probabilities. For first tail, probability is 2 over 3 and rest 2 are heads. So 1 over 4 and 1 over 2. For the second case, if first one is tail, it is 2 over 3. 2 over 3. For the second head, it is 1 over 4, and final one is actually non-biased, I mean fair, so it is always half. Plus, if first one is head, it is 1 over 3 and rest 2 are tail, so 3 over 4 and half. Then if we use our calculator, we will get, it is 24, so 2 plus 2 4, 4 plus 3 7. It is going to be, sorry, we made a mistake over here. Second tail is actually 3 over 4, so it is 3 over 4. So 6, 6 plus 2, 8, 8 plus 3, 11. So 11 over 24. Our probability is 11 over 24. Okay. Now, a question may arise in your mind that in the previous solution, we didn't find individual probabilities. We have just multiplied by 3 and 4. Remember, that one was fair and without replacement. For without replacement, it was always uniform, but in this case the all three coins are not of same probability. That means they are biased in different with different probability. That's why you cannot just finding one probability then multiplying by 2 or 3. It will not be logical. So please don't get confused. In this case they are biased and the probabilities are not uniform. So let's see the third one, when probability of, when there are three tails. So if all three are tails, it is 2 over 3 and 3 over 4 as well as 1 over 2 means half. So it is going to be 6 over 24 means 1 over 6. Sorry, 1 over 4. So these are the four possible cases of this probability. Okay. Now we will write the probability distribution table. So our probability distribution table is ready. Now insert the information. The first probability was 1 over 24. Second one was 1 over 4. Third one is 11 over 24 and then 1 over 4. So let us write 1 over, when x is 0, then our probability is 1 over 24. 1 over 24. So these are the probabilities over here. That is when x is 0, our probability is 1 over 24. When there is only one tail, then probability is 1 over 4. When there are two tails obtained, then probability is 11 over 24, and final one is 1 over 4. So that's all about the probability distribution table of this given scenario. Let's see the next question. The next question has been selected from paper 9709/55 for the session May June 25, and the first question belongs to the topic we are discussing now. Two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 are thrown. The two scores are noted. The random variable x is defined as follows. If the scores are equal, then x is equal to 0. If the scores are not equal, then x is the larger score. Okay, so as both of the dice are fair, so we will have to first of all draw the scenario that, so these are the table we can prepare the possible cases. Well, if both of it is written, if the both the scores are same, then it is 0. Okay, so let us say from the first dice there is 1, and for the second dice also 1, so it is 0. So is over here, first dice is showing 2, second dice is also showing 2, 0, then this is 0, 4 minus 4 0, then 5 minus 5 0, and 6 minus 6 it is 0. Then the difference, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and 6 minus 1 is 5. Then 2 minus 1 is 1, then 3 minus 1 is 2, 4 minus 1 is 3, 4 as well as 5. Okay, then 3 minus 2 is 1, 2, 3, 4. Then this is 3 minus 3 is 0. Then 4 minus 3 is 1, 2 as well as 3. Then 1 as well as 2. Then 6 minus 5 is 1. Well, then 2 minus 2 is 0. But 2 minus 3 is 1. Then 2, 3 as well as 4. Then it is 1, 2, 3. This is 1, 2, and that is, this 2 should be over here. Okay, so these are the possible outcomes when both the dice are thrown. Finally we made a mistake. Actually it should be 4, 2 will be over in this upper row, then it will be 1. Okay, so total there are 36 outcomes, we know. Now our probability distribution table. Okay, let us draw the table. This is our probability distribution table. Now we are going to insert. There are there are total 6 digits starting from 0 until 5. Okay, so now we are going to just substitute the values. Let us see how many zeros are there. The 1 0, 1, 2, 3, 4, 5, 6. Total outcome is 36. Out of 36, there are 6 zeros. That is 1 over 6. So first one is 1 over 6. 1 over 6. Now how many ones are there? Let us count the ones. How many ones are there? Number of ones is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 9 over 36. That means 1 over 4. 9 over, sorry, is it 9? Or should it be 10? Let us count once again. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, there are 10. So 10 over 36 means 5 over 18. 5 over 18. Then the how many twos are there? Let us see 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 twos. So 8 out of 36 means 2 over 9. 2 over 9. Then how many threes are there? 1, 2, 3, 4, 5, 6. So it is 1 over 6. 1 over 6. Then how many fours are there? 1, 2, then 3 and 4. 4 fours are there. So it will be 1 over 9. 1 over 9. Then how many fives are there? 1 5 and then 2 5. There are only 2 fives. 2 5. So it is 2 over 36 means 1 over 18. 1 over 18. So that's all about our probability distribution table of these two coins. Let's see the next question. No, I think this is the final question of this session. Well, our present topic is a binomial distribution. And for binomial distribution, I have chosen a paper 9709/51 for the session May June 25. And we are going to solve question number 4. But all the question, every part of question number 4 doesn't belong to binomial distribution because A belongs to normal distribution. So let's see question number B. Question number B says, in this Saturday's event, 60% of the competitors had times less than 36 minutes. 9 competitors who took part in this Saturday's event are selected at random. Find the probability that at least 2 and fewer than 8 of these competitors had times less than 36 minutes. Well, so we can start our writing. X belongs to binomial distribution. X binomial distribution, and you know the parameters of binomial distribution are total number of experiment as well as individual probability. So total number of experiment, I mean competitors, is 9. So total number of experiment is 9, and the other parameter is individual probability, which is 60%, means 0.60. Well, then we will have to find the probability at least 2. That means it will be more than 2, including 2 until less than 8. Look at this, 2 is inclusive but 8 is not inclusive. That means less than 8, including 2, it is actually from 1 until more than 1 and less than 8. It can be written in this way. That means 2 competitors are included but 8 is not included. I am going to clarify this. What does this scenario actually means? Let me show you. There are total 9 people. Okay, so let us write 1, 2, not this way. Yes, so 1, 2, 3, 4, 5, 6, 7, 8, as well as 9 competitors. Out of 9, they have told that including 2. Our probability should be found for this portion 2 until less than 8. Okay, we cannot include 8. Okay, so what does this means? The probability of these x is equal to 2, x is equal to 3, 4, 5, 6, 7. Then if we find the probability in this way, in the straight way, then it may take longer time. Rather, what we will do, out of this 9 people, look at this one, first people is not included. First people is not included. Eighth people is not included. 8 people is not included, and 9 people are not included. Again, there is 0 also. Sorry, I didn't write 0. There should be 0 over here. 0. So 0, 1, 8, 9. These 4 people are not included. These 4 people are not included. So what we can do, from one whole probability, if we subtract 0 people, probability of 0 people, probability of 1 people, probability of 8 people, and probability of 9 people, then we will find the probability of this box. That means 2 including, that means 2 until 7. 2, 3, 4, 5, 6, 7 people's probability. I think you got my point. So there are two ways. One way is if we start from probability of 2 people, probability of 3 people, probability of 4 people, 5 people, 6 people, and 7 people. On the other way, we can do from 1, from all of the probability, whole probability. If we subtract probability of 0 people, probability of 1 person, probability of 8 people, and probability of 9 people. If we subtract these 4, then we will get the probability of these people, 2 people, 3, 4, 5, 6, 7. I think you got my point. So let us follow the second method. In second method, what are we doing? We are, from whole of the probability, will subtract. Whole probability means 1. From 1 we will subtract when x equal to 0. That means there is no competitor. Then we will subtract when x equal to 1. There is only one competitor. Probability of one competitor. After that we will subtract when probability of 8 people. Then we will subtract probability of 9 people minus probability of 9 people, 9 competitors. I think you got my points. You could do in the other way also. That means finding the probability of 2, 3, 4, 5, 6, 7 people. Remember, 2 is included, but 8 is not included. That's why we have subtracted 8 and 9. Then you know how to write the binomial formula. Yes, it's 1 minus total number of people or competitors is 9. So 9, choose from 9 we are choosing no one. So 9 choose 0. So probability of 0% it is 0.60. How many? On there is no people. That means all the people are, all the competitors are had taken more than 36 times. So for more than 36 minute is 0.40. How many times? How many minute? How many times? 9 times. Here we may write probability of taking less than 36 minute is 0.60. So probability of taking more than 36 minutes, less than 36 minutes is 0.60, and more than 36 minutes will be 0.40. From 1 we will do subtraction. Well, so the second one, when there is only one competitor who took less than 36 minutes, so out of 9 only one, 9 choose 1 who took less than 36 minutes, probability is 0.6 for 1 and 0.4 for rest of them, that means 8 people, minus out of 9, 8 competitors took less than 36 minutes, means probability is 0.6. That means only one person, one competitor took more than 36 minutes, whose probability is 1. So it will be 8, the other one is 1. Then the final probability, 9 out of 9 people. 9 out of 9 people has taken time less than 36 minutes. So probability is 0.6. All 9 people. There is no competitor left who took more than 36 minutes. So I will have to accommodate this just beside this, zero point 0.4 raised to 0. This is what the scenario is. From whole probability, we are subtracting the probability of 0%, 1%, 8%, and 9%. That means this probability of these 4 parts are being subtracted from 1. Okay. Now, if we write 1 minus 9 choose 0, means it's actually 9. Because if you choose no one from 9 people, there are 9 ways to choose them. And as exponent is power is 0, so it is 1. It means simply zero point 0.4 raised to 9 times. Minus 9 choose 1 from 9 people. If you choose one by one, there are 9 ways to choose them. And 0.6 and 0.48 times. Second one has gone. Third one has gone. Then the fourth one, 9 choose 8. This is also 9. From 9 people, if you choose 8 people, so there are 9 ways to choose them. So it is going to be 9 and 0.6 raised to 8 and zero point 0.4 only 1. Then 9 choose 9 is actually 1. If you choose 9 people from 9, there is only one way. If you choose all 9 people, 1. And our probability is 0.6 raised to 9. And as the second part is 0.4 raised to 0 means 1. So there is no necessity of writing 1. In the first one, we made a mistake. It should not be 9 actually. If we choose no one from 9, it is actually 0. I mean one way. Okay, from 9 people, if you choose no one, then there is only one way for choosing no one. So our probability is going to be 1 minus 0.4 raised to 9 minus 9 into 0.6 into 0.4 raised to 8 minus 9 into 0.6 raised to 8 into zero point 0.4 minus 0.6 raised to 9. Then finally our probability is going to be, let me write just over here, our probability is going to be 0.926 if we round it up to 3 significant figures. 0.926. That is what the solution to first question. Let's see another question. The next question has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 7. Let's see what question number 7 says. Actually, the first part of this question is normal distribution, which doesn't belong to our today's topic. Then let's see B, what B says, and the mean second part. Second part says that the masses of adult kestrels are normally distributed with mean mu kg and standard deviation sigma kg. It is known that 20% of adult kestrels have mass greater than 0.202 and 28% have mass less than 0.185 kg. Find the value of mu and the value of sigma. This also belongs to normal distribution, but one information is necessary for us, that is when the mass is greater than 0.202 kg, then probability is 0.20. Let's see question number C. Actually, we will have to solve question number C, which says 10 adult questions are selected at random. Find the probability that fewer than 3 have masses greater than 0.202 kg. Okay, initially I forgot to mention one thing. How will you know that a distribution is binomial or not? Binomial distribution, remember, always there will be number of total experiment is given and individual probability is given. If number of total experiment and individual probability is given, then that distribution belongs to binomial distribution. Well, so the as here 10 adult kestrels have been selected, so this is binomial distribution. Let us start writing with binomial distribution, and the parameters of binomial distributions are total number of experiment is 10 and the other one is individual probability. Just we have seen that the masses which are greater than 0.202 kg is probability is 0.20, 20%, 0.20. So P is equal to 0.20, that means mass greater than 202 is 0.20. Definitely Q is going to be, that means masses less than 0.202 kg is going to be 0.80, 0.80. Now they have told us to find the probability of fewer than 3. So less than 3. For less than 3, it means there is only one kestrel, x is equal to 0, or x is equal to 1, or x is equal to 2. So there are 3 remaining probability. For less than 3, there may not be any of the birds, or one bird or two birds. So if we choose no one from 10, it is 10 choose 0. That means no bird has mass greater than 0.202. So it is going to be our probability is 0.20, 0.2 raised to 0. That means all of them, rest of them, that means 9, 10 is having 0.80, 10. Okay. Plus, if there is only one bird, 10 choose 1. So probability of having mass greater than 0.202 is 0.2, only 1, and rest of them is less than 0.202. That means 9 birds. Then if there are 10 choose 2, so 2 birds are having mass more than this 2, more than 0.202 kg, and the rest 8. There are 8 remaining. 8 birds will have the mass less than 0.202 kg. Okay. So let us calculate this. From 10 people or 10 birds, if we choose no one, there is only one way. And 2 raised to 0 is also 1. So ultimately it is 0.8 raised to 10. Plus 10 choose 1 means actually 10. From 10 people, if you choose only one people, there are 10 ways to choose them, into 0.2 into 0.8 raised to 9. Plus from 10 people, if you choose 2, that is actually 10 into 9 into 8 factorial. I'm solving it manually. It is 2 factorial into 8 factorial. then our probability are 2 raised to 2, 2 raised to 2, 2 raised to 2 and 0.8 raised to 8. Okay, equal to, and here we can do some resolution. 8 can cancel out the other 8, and 2 factorial means 2, so 2 5, it is actually 45. This is actually 45. Okay, now using our calculator we will get the probability is going to be 0.8 raised to 0 plus 10 into 0.2 into 0.8 raised to 9 plus 45 into zero point 0.2 square into 0.8 raised to 8. So finally our probability is going to be 0.678. Okay, so this is what our probability. Let's see the next question. The next question has been selected from paper 9709/53 for the session May June 25, and we are going to solve question number 2, which says at a large college all students who study science also study exactly one of art or drama or music. 20% of these students study art, 45% study drama, and 35% study music. 3 students are selected at random from the students who study science. Find the probability that at least one of these students studies drama. So, as the total number of experiment is given and individual probability is also provided, so it belongs to binomial distribution. Let us start our writing. X belongs to binomial distribution and the parameters are total number of experiment is 3 and individual probability. Look at this, probability of who study drama. Okay, so for drama the probability is 0.45. 0.45. That means for starting drama probability is 0.45. P is equal to 0.45. 0.45, whereas those who do not study drama, their probability is 0.55, individual probability. So let us start our solution. Probability of at least one, that means it may be more or at least one. So it is actually there are 3 people, so there may be only one person or only 2 students or all 3 students took drama. X equal to 3. So when only one student takes drama, we will write out of 3 we will choose 1, and for taking drama probability is 0.45, only one people. Okay, that means rest 2 are not taking, so for not taking probability is 0.55, it is 2. Then the second probability of 2 students is out of 3, 2 student has taken drama. So for drama probability is 0.45, number of students is 2, that means only one student didn't take. So for the other student probability is 0.55. Okay, then if all 3 students take drama, or all 3 students, 3 out of 3, all 3 students have taken drama, for which the probability is 0.45 raised to 3 raised to 3, and no one took other subjects, so their probability is 0.55, it is 0. Okay, then if we use our constraints, then 3 people, if we choose 1 people one by one, there are 3 ways. So 3 into 0.45, 0.45 into 0.55 square, 55 square plus from 3 people, if we choose 2 people, there are again 3 ways. Okay, so it will be 2 by 2. If you keep on choosing, then there are 3 ways to choose. Then their probability is 0.45 squared into 0.55 once, only one student. Then from 3 people, if we choose all 3 people, there is only one way to choose, and 0.55 raised to 0 is also 1. That means, so finally it is going to be 0.45 raised to 3. So finally our probability is going to be, if we use our calculator, it will be just 0.834. 0.834 is our final answer of the students who study more than, at least one students who study drama. The next question says 10 students are selected at random. Now number of students is 10, and we will have to find the probability that more than 7 study art or music. Okay, so for art or music, let us write x belongs to binomial distribution. X belongs to binomial distribution. The parameters are 10 as well as probability of studying art or music. Let us see how many students take arts. Let us see how many students are there. What is the percentage of students who take art or drama? Okay, it is art or music, sorry, art or music. Okay, so let us see. For art there are 20%, and for music there are 35%. So total number of probability is going to be 55. 35 plus 55. So remember, it is or. Okay, or is equal to, it is written art or music, and we know or means addition of the probability. Look, this is mentioned or. So as the word or is mentioned, art or music, that means all of the students together, the probability is 0.55. 0.55 is individual probability. That means our P is equal to 0.55, whereas those who are out of these two subjects, Q is 0.45. So let us see our probability. They have told that more than 7, so X is more than 7 students. Okay, now for this, what are the possibilities? More than 7, total number of students is 10, so more than 7 means 8, 9, 10. So let us find the probability of X equal to 8 when 8 people took drama or music, art or music, or there might be 9 students, or there might be 10 students. Okay, so let us write out of 10, if 8 chose art or music, so 10 choose 8, and probability of choosing art or music is 0.45. 8 students chosen this, so rest 2 students didn't choose. 0.55 square plus out of 10, 9 students chose this, so 0.45 raised to 9. Only one student is left who didn't take, so it will be 0.55 once. After that, out of 10, if all 10 students, 10 choose 10, all 10 students have taken art or music, for which the probability is 0.45, all 10 students, and no students is out of art or music, so it is 0, no student. If we simplify more, we will get 10 choose 8. Okay, so 10 I am solving it manually. 10 into 9 into 8 factorial over 2 factorial into 8 factorial 0.45 raised to 8 and 0.55 raised to 2 means squared. And from 10 people, one by one, if we choose 9 people, there are 10 ways to choose. So 10 into 0.45 raised to 9 and 0.55 ones. Then if we choose all 10 people, from total 10 people, there is only one way. So it will be 1 and 0.5 raised to 0. This is also 1. That means there remains only 0.45 raised to 10. Raised to 10. Now if we simplify more, if we simplify, 8 can cancel out the other 8. 90, if 90 is divided by 2, it is going to be actually 45. This is 45. So using our calculator, we will get 45 into 0.55 raised to 8. Sorry, we have been making great mistake. Our probability was 0.55. Instead of 0.55, I have written 0.45. So everywhere it will be replaced. So we will have to rectify this. Actually, this one is going to be, this one is 8 and here it will be 2. And then this is going to be 10, not 10, it is going to be 9 and it is 1. So if we use our calculator, it is going to be 45 into 0.45 square into 0.558 plus 0.451 and 0.55 raised to 9 and 0.55 raised to 10. It is going to be, our answer is going to be finally 0.0996 after rounding it up to 3 significant figures. So that is what the answer to the second part of this question. Let's see our next question. So the next question has been chosen from paper 9709/55 for the session May June 25, and we are going to solve question number 3 under the mentioned topic. In a certain large school, on average, 2 pupils in 5 have music lessons. A random sample of 80 pupils from this school is chosen. So surely this is binomial distribution. Use an approximation. Approximation belongs to actual normal distribution. So this part of the question doesn't belong to our mentioned topic. Let's see question number B. B says a random of 10 pupils. Yes, this belongs to binomial. A random of 10 pupils from this school is now chosen. Find the probability that no more than 2 pupils have music lessons. Then let's start our solution. X belongs to binomial distribution. And for binomial distribution, the parameters are total experiment as well as individual probability. Let us find the probability of students who took music lessons. Okay, so for music lessons, it is written every 2 out of 5. That means 2 out of 5 means this 0.4. So if probability of taking music lessons is 0.4, then the probability of not taking music lessons is 0.6. So our P is 0.4. P is 0.4. Surely our Q is P is equal to 0.4 and Q is going to be 0.6. Well, let us find our probability. Probability of X, more than 2 peoples. There are total 10, more than 2 people has taken, what is written, that no more than, sorry, it is not more than, it is no more than two people. No more than two people means it is maximum two people or less than two people. So what is this? It means actually there may be none of the students who took music, or there might be only one student who took music class, or there might be two student maximum, two student who took music class. So this is the scenario. If none of the student out of 10 takes music class, it will be from 10 no one has chosen music. So probability of music class is 0.4 and no one, that means all the 10 students took other subjects 10, or there is only one out of 10, 10 choose one has chosen music class, 0.4 one student, and rest 9 students didn't take music class, 9, or there may be 2 students out of 10. So 10 choose 2 students, out of which 0.4 raised to 2, and rest 8 students didn't choose music class, 0.6 8 students. Well, now if we calculate this, it is going to be, now from 10 people, if we choose no one, there is only one way to choose this, and raised to 0 means 0, so it is actually 0.6 raised to 10. And from 10 people, if you choose one by one, then there are 10 ways to choose them. 10 into 0.4 into 0.6 raised to 9. Okay, then from 10 people, if you choose 2, it is actually 10 into 10 times 9 times 8 factorial over 2 factorial into 8 factorial, and 0.4 square into 0.6 raised to 8. If we simplify more, 8 can cancel out this, and this is 90 divided by 2, it is 45. Okay, 45. Now if we use our calculator, we will get that our probability is 0.6 raised to 10 plus 10 into 0.40 into 0.6 raised to 9 plus 45 into 0.4 square into 0.6 raised to 8 equal to 0.617, sorry, 167. 167 is the probability of 2 students taking music class or music lesson. So that's all about our binomial distribution. Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve some of the questions on stem and leaf diagram. Let's see which question we are going to solve. First of all, this particular question belongs to paper 9709/51 for the session May June 25, and we are going to solve question number 3. Let's read the question. The question says, last Sunday, teams of runners took part in a charity event. The time taken in seconds to run 50 meters was recorded correct to one decimal place for each runner. The times recorded for 11 runners from each of the gulls and the herons are shown in the table. Question says, draw a back-to-back stem and leaf diagram to represent this information with gulls on the left-hand side. Well, these is one of the easiest topics of probability and statistics. So let's start our solution. Let's draw the stem first. Well, on the left side there will be galls because there is a specific information that on the left side there will be galls. So let us write galls on the left leaf, galls, and this is the stem, and on the right side there will be herons. Well, now let us substitute the times taken by each of the runners. So what is the minimum value? So let us see what is the minimum value in any of the cases. Minimum values start from 7. So let us write 7 in the stem. After that there comes 8, then 9, last of all 10. 10. Let's see what are the values to be beside 7 in galls. Beside 7 there is only one value, which is 9. So let us write 9. 9. Then after 8, beside 8 there is 2, 3, 6, 6, 8. So let us write in sequence 2, 3, 6, 6 as well as 8. After 9, on the left side it is going to be 2, 7, 8. 2, 7 as well as 8. Then beside 10 there is a 0 as well as 4. It is already arranged in the girls team. All the times are already arranged, so it is 0 as well as 4. 0 and 4. Well, now this is the turn of herons. Herons are in disorder. We will have to arrange them in ascending order. So beside 7 there remains 1, 3. Beside 7 there is nothing actually. Beside 8 there is 1, 3, 5, 7. This 1, then 3, after that 5, then 7. So 1, 3, 5, 7 beside 8. 1, 3, 5 as well as 7. Then beside 9 there is 1, no, there is no 1, 2, 3, 5, 7, 9 two times. 2, 3. So let us write 2, 3, 5, 7, 9 twice. Okay. Then beside 10 there is only one value, which is 8. 8. So this is the stem and leaf diagram. After completion of writing this, we will count whether we have written all of them properly or not. There are total 11 players they have mentioned. Let us see. It is written 11 players. Okay, 11 runners or 11 players. So did we complete writing all 11 or not? Let us count. 1, 1, 5, 6, 6, 3, 9, 11. Okay, then 4, 4, 6, 10, 11. We have written all of them. Now remember, after drawing the back-to-back stem and leaf diagram, there must be the key written. So key is, we will have to write key. Remember, this is the part of your solution. Key is, suppose we are picking up this 8, 2 and 1. So 2, then 8, then 1 means, what does this mean? Means 8.2 seconds. 8.2 seconds for 2 seconds for girls. For girls. For gulls and 8 point and 8.1 seconds for the next team, herons. For herons. So after completion of on completion of stem and leaf diagram, please don't forget to write the key, because through the key you are instructing exactly what the stem and leaf diagram says. Well, then the next question says find the median and the interquartile range of the times of the runners from the girls. So total there are 11 runners, okay, and for 11 hour we will have to divide it for lower quartile, median and interquartile range. So we will have to find lower quartile first of all. Lower quartile means Q1, okay, or Q3, whatever you tell. Q1, first one is lower quartile, then median, then we will find upper quartile, then last of all IQR, interquartile range. Okay, so lower quartile, how will you find? There are total 11 numbers, okay, 11 players. So 11 plus 1, 11 plus 1. Total there are 11 players. So we will always add up 1. So it is going to be 12 over 4, means third data. This is not this data, remember this is actually position. So this is third data. Third one is our lower quartile. Then what will happen if third one is our lower quartile? Double of this will be median. So sixth one will be our median. Then third one, that 3 3s are 9. So ninth data will be our upper quartile. Then if we subtract lower quartile from the upper quartile, it is going to be our interquartile range. Now let us see what is the third data, a third time. It is about girls. Look at this. The question told not to find from everyone, only from girls. So let us see in girls third data. 1, 2, 3. Remember, if you count in both cases, you will have to count from the same direction. We are counting from closer to far. Okay, this is our direction of counting. So our third data is which one? First, second, third. This is our third data. Then sixth one is our median. Sixth data is going to be, then sixth data, 3, then 4, 5, 6. This is our sixth position. Then our ninth position. Then if it is 6, then 7, 8, ninth position is this. So our lower quartile is 8 and 3, that is 83, means 8.3 second, 8.3 seconds. Okay, then our median is going to be 8.8 seconds, 8.8 seconds. Then our upper quartile is 9.8 seconds. 9.8 second is our upper quartile, as we have encircled over here, that is 9.8 seconds. Then our interquartile range is going to be actually subtraction between upper quartile and lower quartile. So the difference between 83 and 98 is 1.5. Our IQR is 1.5. Okay, and our median is, this is our median, already we have written. So here we can write our answer. Okay, there are two answers. First one is median. So our median is, this is one of the answer, and interquartile range is 1.5 seconds. This is also another answer. So that's all about the solution to this question. That means drawing the stem and leaf diagram as well as finding the median and IQ, I mean interquartile range. Let's see the next question. The next question we are going to solve belongs to paper 9709 slash May June 25. Okay. The paper code is 9709/55 for the session May June 25, and we are going to solve question number 5 of this paper. Let's see what the question number 5 says. It says the smarts and the teasers are two quiz teams that each contain 11 members. Both complete a puzzle, and the following table gives the times taken in minutes by the members of each of the teams. Smarts above the upper column, I mean upper row of the table, and teasers are written, time of the teasers are written in the lower row of the table. Represent this information in a back-to-back stem and leaf diagram with smarts on the left hand side. So on the left side there will be smarts. Let's start our solution. Let's draw the stem and leaf diagram. On the left side, there will be smarts as they have instructed. So let us write smarts on the left hand side, and in between them there is stem, and on the right leaf there will be teasers. Teasers. Well, so first of all, we'll have to find the number. The times are not arranged in any order, so we'll have to arrange them in any order. I mean, in the ascending order, we will arrange them. So first of all, let us see is the lowest time for smarts. It's actually 9. So there will be 0 is the beginning, then 1, 2, 3, 4. The maximum is 4. So minimum is 0 and maximum is 4 in the stem. It is 0, then 1, 2, 3. Finally, it will be 4. 4. Then let's insert the information for smarts on the left. So first one is minimum value is 9 seconds or 9 minutes, whatever, 9 minutes. Then there comes 11, 13, 18, and again 18 two times. Once 18 and another 18. There are 18 two times. So it is 1, 3, 8, 8. 1, 3, 8 as well as 8. Let's see beside 2 more than 20 seconds how many gamers or puzzle solvers are there. 2, 8, 9. It is 22, 28 as well as 29. Then beside 3 more than 30 minutes is 30 and 38. 0 as well as 8. Then only one gamer took more than 40 minutes, which is 41 seconds. Then this is the turn of writing the times taken by the teasers. Teasers, they didn't take any time less than 10. So start from 1. They have taken 12, 15 and 18. 12, 15 and 18. So 2, 5 and 8. 2, 5 as well as 8. After that, more than 20 seconds are there. 21, 25 and 25. So 21, 25, again 25. That means 1, 5, 5. After that, more than 30 seconds are there are 4 students. 2, 4, 2, 6, 7, 9. 2, 6, 7 as well as 9. I mean 39 seconds. Then finally, none of the students from teaser has taken more than 39 seconds. So that is maximum. Now let us see whether we have written all of the times of them. There are total in each member there are 11. In each team there are 11 members. Okay, let us see whether we have written all 11 or not. If we count the times we have noted down of smarts, we will get 1 1 plus 4 5 5 3 8 8 3 11. For smarts, all of them have been written. Now teasers, the 3 3 6 6 4 10. That means we skipped one of the timings, one of the times, and which is, look at this, 39 two times, 39 two times, but we have written once, so one more time it should be written. Okay, this is the stem and leaf diagram. Remember, there is one more part is left to be written for the stem and leaf diagram. Always upon completion of drawing the stem and leaf diagram, we must not forget to write the keys. Key will be key. We can choose any of the values from here. Let us choose this one. We are choosing this box. Okay, you can choose any of the boxes. It is not a big deal. If we write here 2, then 2, then 1, means, what does it means? We will have to clarify. Means 22 minutes for 22 22 minutes for, as it lies on the left side, this is the time for times for smarts, for the smarts, or if we write only smarts, it's sufficient. And 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 let us write over here, and 21 minutes on the right side, 21 minutes for the other team, which is named as teasers. So that's all about the stem and leaf diagram of this question. Let's see what's more. Since there is no more question left in the May June 25 sessions on the same topic, I mean stem and leaf diagram. So this is the final question. We have solved two of the question on the basis of this, and some more questions. Only I am actually categorizing the questions on the basis of session. These two questions belongs to May June 25 sessions. Then we will solve same, that mean questions on same topic from October November 24 sessions, and then May June 24 sessions, and so on. So I have arranged the questions in session wise they will be solved. So thank you all for being with me, and may Allah bless all of us with beneficial knowledge. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve some questions on a tree diagram. And the first question we are going to solve belongs to paper 9709/53 for the session May June 25. And we are going to solve question number 5. Let's see what it says. The question says bag A contains 6 red marbles, 5 blue marbles, and 1 green marble. Bag B contains 5 red marbles and 3 blue marbles. A marble is chosen at random from bag A and placed in bag B. So one marble has been taken from bag A and it has been placed in bag B. That means number of total marbles in bag B will increase by 1. A marble is now chosen at random from bag B. Then from the second bag also one marble has been chosen. Draw a tree diagram to represent this information, giving the probability on each branch. So let us start our solution. As there are 2 bags, so there will be 2 trees. So first one is bag A and second one is bag B. Okay, so for bag A there are 3 different kinds of marbles. 3. One is red, blue, as well as green. So there will be 3 branches of this tree. and they are red. First one is red, blue, as well as green. Green, okay. The third one is green. It is going to be green for the first bag. Then for the second bag, there are red, red marbles and three blue. And there are two what? There are two branches for the second bag. So there will be only two, only two. But here there will be one more, because from the first bag there are three different kinds. Green is uncommon, okay. So for green there will be another branch in the second tree. So it is red as well as blue, red as well as blue, and red, blue. This is our blue, or let me write blue, the second branch. It is blue, then the third one may be green. Okay, now we are going to insert the probabilities. Now we are going to insert the probabilities. Look at this. In the bag 1 there were 6 plus 5 11, total 12. So, and out of 12 red there are 6, so it is going to be 6 over 12. 6 over 12 for red. And how many blues are there? So it is 5 over 12. 5 over 12. Then there is only one green marble. It is going to be 1 over 12. Now for the second bag, as this marble has been given in the second bag, so total number of marbles were in the bag B was 5 plus 3 8, and one was given from bag A, so it is going to be 9. Out of 9, 5 are red, so it is going to be 5 over 9. 5 over 5 over 9. Sorry, it should not be 5 over 9. There were 5 red marbles, but one has been given from bag A, so number of red marble is also 6. So it is going to be 6 over 9. 6 over 9. 6 over 9. Then first marble was red. Now if we choose blue from the second marble, there will be no increase in blue marbles. Blue will remain same, which is 3. But as one marble has been given, one red marble has been given to bag B, so total number is going to be 3 over 9. Well, then the second branch, here there were 5 marbles of blue. In the second bag, in the second bag there are 5 red marbles, okay. So if one marble is given, so total is increased, means total is going to be 9. Total is 9, but red marble has not been increased because blue marble has been kept into bag B. So red will remain same. It is 5 over 9. 5 over 9. Then blue, first one was blue and second bag is also blue. That means one blue marble has been given. That's why number of blue marble will increase, which is 4, and total number of marble is 9. So 4 over 9. Now third branch, from the first bag we have chosen a green marble, and green marble is kept in the second bag. So red marble has not been increased, but total has been increased. Total is 9. In every case one marble has been increased, so it is total is 9. Total is 9. Here also total is 9. One marble has been increased. Now let's see what about red. Red has not been increased because the green marble has been given to the second bag. So green will increase, but not red, neither red nor blue. So red was 5, we will just write 5, and blue will not also increase. Blue there were 3, so still there are 3, so 3 over 9. But about green, there was no green marble in bag B. There was no green marble. Look at this, but one marble has been given. That's why it is newly getting one marble. So it is all about finally 6 over 9, 3 over 9, 5 over 9, 4 over 9, and 5 over 9, 3 over 9, and 1 over 9. That's all about the tree diagram of this scenario. Well, then let's see what question number B says. The next question says, find the probability that both marbles chosen are the same color. So, for being same color, probability of same color. Probability of same color. So, what are the possibilities of being same color? Suppose first one was red and second one is also red. Or it may happen first one is blue as well as second one is also blue, or from the first bag we have chosen first one was green as well as the from the second bag also we have chosen a green marble. So it is RRBBGG. Let us pick up the answer from the previous question, from the previous solution, RR. Okay, so RR is this one as well as this one. So 6 over 12 into 6 over 9. Then for blue, this one is blue 5 over 12 and another blue is 4 over 9. Then green, first green was 1 over 12, second green was 1 over 9, because both of the we are finding the probability of same color, red, green, or blue. So let us insert this information. Let me show you. If I zoom out, you can see it well. That is red, green, blue. I think I can mark in a different way. So for red, let me encircle with red color, red. Then blue. For blue, this one is blue as well as this one is also blue. Then for green, first one is green and second one is also green. Then easily we can identify. So let us insert these probabilities in the next question. Okay, for red, these were 6 over 12, 6 over 12, 6 over 12 and 6 over 9. 6 over 9, because one more marble has been given in the second bag. Then for blue, we got 5 over 12, 5 over 12 first bag, and from the second bag it was 4 over 9. There were 3, one has increased. Then for green, first there were 1 marble in the first bag, in the second marble also there is 1 marble out of 9. So our denominator is getting same. It's 9 12 are 108 and numerator 36 and 20, so 56 and 1, it is going to be 57. So finally our probability is going to be, if we divide 57 by 108, our probability is going to be 0.528, 0.52 as well as 8. That's all about this simplest solution. Let's move on to the next question. We are going to solve under the same topic. The next question we are going to solve belongs to paper 9709/55 for the session May June 25, and we are going to solve question number 4. Well, let's see what it says. Students applying to Drydale College take an entrance test. A student is either accepted or rejected or required to take another test. There are 3 possibilities: either accepted or rejected or another test. Okay, with probabilities 0.3, 0.2 and 0.5 respectively. When a student takes a second test, the outcomes and probabilities are exactly the same as for the first test. A student who has to take the third test is either accepted or rejected. Accepted with probability 0.25 or rejected with probability 0.75. Draw a tree diagram to illustrate this information. Okay, so let us start our solution. For the first chance, there are three possibilities, and they are either accepted or rejected or chance for the third test. Okay, then it is accepted or rejected or second test. Okay, test again. Then whenever he is given a second chance, then again he has given three more. He has three possibilities, either accepted or rejected or retest. Okay, then after the second chance there is only two possibilities, either he will be accepted or rejected. This is what the scenario is. Now we are going to insert the probabilities. Okay, well, for first acceptability is, these are the probabilities, corresponding probabilities. So zero point 0.3, zero point 0.2 and zero point 0.5. Let us write here 0.3, zero point 0.2 or zero point 0.5 is the possibility of having second chance. Then if he takes part for the second time, acceptability, rejection and second opportunity are exactly same, so it is going to be 0.3. For first two chances, probabilities are same, so 0.3 or 0.2 of being rejected, or there may be third chance is given with same probability. Okay, now for the third chance there is either acceptability or rejection. Acceptability is 0.25 and rejection is 0.75. So it is 0.25, 0.25, as well as for rejection it is going to be 0.75. So that's all about this tree diagram of this question. Let's see what the next part of the question say. It says, find the probability that a randomly chosen student who applies to Drydale College is accepted. So for probability of acceptability, if we write here probability of acceptability, exception, acceptance, acceptance. Okay, probability of acceptance. So the student might have succeeded in the first probability. So first accept, he was accepted in the first case, or he was given second opportunity, that means second test, then he got succeeded and accepted, or he might be failed two times. First one is, that means he failed, I mean he tried for the second chance and he took the second chance and finally he was accepted. So these are the possible cases for the student of being accepted. Let us see, if someone passed at the first test in the first chance, so his probability is going to be 0.3. It is 0.3 for the first. This is the possibility of passing in the first chance, 0.3, 0.3. Or first he was given an opportunity for the second chance, it is 0.5, then he was accepted. So 0.5 into 0.5, if 0.5 is multiplied by 0.3, then there may be a third opportunity. First time he was given an opportunity for second chance, and again he took the second opportunity and tried for the third chance. So in the third trial, he succeeded. So 2 times t is zero point 0.5. Zero point 0.5 again he was given chance. Zero point 0.5 finally he succeeded with a probability of 0.25. So these are the probabilities. Now if we sum up, it is going to be, using our calculator we find that the probability of a student being accepted is 0.513. If we round it up to three significant figures, it is going to be 0.513 is the probability. So that's all about the solution to this question. And thank you all for being with me. And may Allah bless all of us with the beneficial knowledge. Fi amanillah. Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve some questions on normal approximation to binomial distribution. And the first question we have chosen is from the paper 9709/55 for the session May June 25. And definitely we are going to solve question number 3. Okay, let's read question number 3 of this paper. In a certain large school, on average, 2 pupils in 5 have music lessons. A random sample of 80 pupils from this school is chosen. Use an approximation to find the probability that fewer than 27 pupils have music lessons. So that's all about the question. Now we are going to approximate this normal distribution to binomial distribution. Let's start our solution. We know that whenever the word approximation mentioned, it means the distribution is given in binomial, which is to be converted to normal distribution. So let us write first, it is given as binomial distribution, and we know the parameters for binomial distributions are n and p. N is the total number of experiment is 80, and p is the individual probability. What is the probability? Probability was 2 pupils in 5. That means p equal to, p is equal to 2 over 5. 2 over 5. So what is going to be the failure in each case is q is equal to 3 over 5. So if P probability of music class is 2 over 5, then probability of not having music class is 3 over 5. So our P is, probability is 2 over 5, and 2 over 5 can be written as zero point 0.4. Let us use decimal point, 0.4. So this is our n, this is our p. Let me show you with different color. N, this is p. And if we convert this distribution into binomial, I mean normal distributions, for normal distribution n, x belongs to node n, x belongs to normal distributions, and the parameters for normal distributions are mean as well as variance. So mean is actually n into p. If we multiply n and p, it is mean. So 80 into 4, that is 32. 32, and the other parameter is variance. Variance is npq. So if you multiply 32 by zero point 0.6, it is going to be 19.2. So let us write 19.2. 19.2 is our variance. So this is how we should start our solution, and this is mean is np, and our variance is npq. Npq, I will have to use different ink. Then np as well as q is variance. I think you got my points. Well, now they have told us to find, to approximate. So they have told us to find the approximation for fewer than 27 pupils. Okay, so let us write probability of x less than 27. So here there is a crucial point when we apply the approximation concept. Remember, it is instead of 26, I mean 27, it is going to be 26.5. Now the question is, why did we do this? It is actually continuity correction. Continuity correction means, you know, that the question is given in binomial distribution, whereas we are converting it into normal distribution. Binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. That's why from binomial to normal we will have to convert it into continuous random variable. That's why they told it's less than 27, so we will have to subtract zero point 0.5 to make it correct in continuity. Now we are going to standardize this score. So probability of, you know how to form the z score. Z is less than x minus mu zero point 0.5, and our mu is actually mean value. Mean value is 32 over standard deviation. Standard deviation is the square root of the variance. Variance is 19.2, so it is 19.2. Well, then if we simplify this, our z score is getting less than, it must be negative because 32 is negative term is larger, so negative 1.255, 1.2 as well as 55. After that we will draw a normal graph. Okay, let us draw a normal graph. Suppose this is our normal graph, and as our standard deviation is z score is negative, suppose this is, here is our z score. Okay, z score is 1, suppose it is 1.2, 1.2. So which part is our probability? This region, this dark tiny region is our probability. Well, now, if I draw another curve, another graph, look at this. So from this one, we require that here it is 0. Since the normal function graph is symmetrical, so we can assume that, we can say that this part, this tiny part of the second diagram must be equal to the tiny part lying on the left side of standard, I mean mean value 0. Okay, so we require actually this tiny part where the z score is going to be 1.2. Now what we can do, actually we are going to use the normal distribution table. In the table, none of the probability is less than half, so always the greater probability, we can find the greater probability for corresponding z score. So what we will do, we will subtract this large part for corresponding z score. This large part we are going to subtract this red part, and surely we will get that tiny dark part. I think you got my point, that whenever the z score is negative, or our probability is tiny part, then we will find the whole probability. Whole probability is actually 1. So from 1, if we subtract the large part, we will get smaller part, because in the normal distribution table all the probabilities are more than 0.5. So what we will do always, if we require the smaller part, smaller region, then from whole probability we will subtract the larger region. So it can be written or equal to, here I think we could have written equal symbol instead of or. So let us write equal symbol. So we have explained that from whole probability from 1, if we subtract the left part p when z is less than 1.255, then that will be our small tiny part. Okay, now using our normal distribution table, you will be given a booklet during the exam. In the booklet there will be normal distribution table. It is, I think, better or more comfortable than using the calculator, because in calculator you will have to change the mode frequently. That's why we are going to use our normal distribution table. Let's see, our z score is 1.255. Okay, 1.2. So first of all we will find 1.2 in the row 1.2. So this is the row 1.2. Then 5 fifth column as well as fifth column. Okay, so for the final fifth column it is actually 10, and first fifth column is 8749. So it is going to be, sorry, not 8749, it is 8944. 8944. If we add up this, then 9, sorry, this one is also wrongly selected, it will be actually 9. Okay, this is 9. So these are our, this should be added to this. So how did we do? We have first selected the row, then first column as well as the final column. And these two quantities, the marked two quantities should be added. If we add 0.8944 to 0.009, it is going to be 0.8953. It should be, the addition should be like this, 0.8944. Then you are going to add up 0.0009. So surely it is going to be 0.8944 plus 9 is 8953. So that is how we can use the normal distribution table very easily. So our final probability is point, and again I am showing you, look at this. Here the probability starts from zero point 0.5, that means more than half. All the probabilities are, the least probability is half, but that means at the midpoint. Okay, at the midpoint. So if we find any tiny part, for that it's better we find the corresponding probability of the greater part, then we will subtract that part from 1, we will get the tiny part. So for tiny region we will subtract the greater part from 1. So it is 1 minus 0.89, 1 minus, it is going to be, let me show you whole of the solution together, or 1 minus 0.8953, 0.89, 0.8953. So finally our probability is going to be 0.105. If we round it up to three significant figures, it is 0.105. So that is what our approximation to this binomial distribution. I think you have understood, as I have clarified every tiny part of this solution. Let's see the immediate next question under the same concept. The next question has been selected from the paper 9709/52 for the session May-June 25. Let's read question number 2 of this paper. It is question number 2. In Milford, 70% of the residents own a bicycle. A random sample of 160 residents is selected use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. Let's start our solution as we did in the previous case. First of all, let us write our P. P is 0.70. P is equal to zero point 0.70. So our Q is going to be 0.30. 0.30 is our Q. So let us write X belongs to binomial distribution, and the parameters for binomial distribution is n into np. N is total number of experiment, which is 120. So 120, and our individual probability is 0.70. If we convert it into normal distribution, X belongs to now normal distributions, and for parameters of the normal distribution we write mean. Mean is np. Okay, so this is n. Let us write here, this is n and this is p. So parameter for first parameter of normal distribution is mean. Mean is np. If we multiply 120 by 0.70, it is going to be 160. Sorry, 120. Sorry, our total random sample is 160. So 160 is it is not 120. Instead of that, it is going to be 160. Let me write 160. So our mean is n into p. If we multiply 160 into zero point 0.7, it is going to be 112. So our mean is 112, and our variance is npq. If we multiply, q is 3. If we multiply by zero point 0.3 by 112, it is going to be 33.6. 33.6. Let me write here np and npq. Yes, so we have written the parameters of the normal distribution. Now we are going to find the probability of x is, it is written more than 120. More than 120. So x greater than 120.5. You have not forgotten that we will have to do continuity corrections, because it is more than continuity correction. Continuity correction is one of the major parts of such solution. Remember, as it is more than 120, so if we do continuity correction, we will add up zero point 0.5, because it is more than the quantity. After that, if we standardize our score, it is going to be z greater than, you know how to standardize this score, our x minus mu, I mean mean. Our x is how much? 120.5. 120.5 minus our mean is 112. And standard deviation. Standard deviation is the square root of our variance. Variance is 33.6. Now using our calculator, we are going to get probability of z greater than, if we use our calculator, it will show 1.466. 1.46 as well as 6. Now we will have to draw a graph to show which part is our actual probability. You know, the normal distribution graph is always symmetrical. Here it is 0, and our z score is 1.466 and it is positive. So suppose here it is 1.4. 1.4. Okay, so which part is our probability? This part, greater part, that means on the right side of this z score, because it is written z greater than. Okay, so these tiny parts, if we want to tiny parts as our probability, what we do, from the previous solution you have come to know that just for tiny part we subtract the larger part from whole probability. Whole of the probability is 1, so we can write here that 1 minus probability of z less than, as the left part is larger, so we are going to subtract the larger part, it is 1.466. And you know that none of the probability, corresponding probability in the probability distribution table is less than zero point 0.5. That's why we opt for right part. So we will find the probability when z score is 1.466, then we will subtract that part from 1. Our whole probability is 1 minus, let us see the corresponding probability when z score is 1.466. 1.4, so 1.4 is our row. 1.4 is our row. This is our row. 1.4, and then 6 6, first digit is 6, the second digit is also 6. First of all, we'll have to decide our row. This is our row and column, first column, then it should be added to another 6. This add should 8 should be added to this. So if we add up this, it is 0.9279 plus 8, as I have shown in the previous one, 0.9279. Well, after that we will add up the final digit 0 0 0. The final digit will be added to the final digit, it is 8. So our probability is going to be 0.9287. So you have understood that our probability starts from zero point 0.5. That is, none of the probability is little part. If you want to find the little part as probability, you will subtract the greater part and you will get the little part. So we did so. Our probability, the greater part is, greater part, as we have seen, it is 0.9287. 0.9287. Now if we subtract this greater part, I mean this red part, if we subtract the red part from whole probability, means from 1, then we will get our tiny, that dark part. This part can be subtracted because all the probabilities given in the probability distribution table is more than 5. That means larger part. If you regard the smaller part, always you will find the corresponding probability of the larger part, then you will just subtract. After subtraction, we will get 0.0713, 0.071 and 3. That is the answer to this approximation. And I tried my level best to explain every tiny part lying in this solution. Let us see one more solution. The next question has been selected from paper 9709/51 for the session May June 25, and we are going to solve question number 4, which says every Saturday a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation is 2.5 minutes. And question number A and B don't belong to our concept of today. Our topic is different, that is approximation. So let us see question number C. Question number C lies on the next page, which says 80 competitors who took part in this Saturday's event are selected at random. So our N is 80. Use a suitable approximation to find the probability that more than 50 of these competitors had times less than 36.0 minutes. So as usual, we are going to write x belongs to binomial distribution, and for binomial distributions our N is 80, and probability, we are going to write the probability when the competitors had time less than 36 minutes. Okay, so for less than 36 minutes, what is the probability? Let us see from the previous page. It is in question number B. Look, 60% of the competitors, here it is written, 60% of the competitors take time less than 36 minutes. So our probability is 0.60, P is 0.60, Q is 0.40. So let us write this. So our P is 0.60, 0.60 is probability. So P is equal to, let me write with different ink. Our P is equal to zero point 0.6 and our Q is going to be 0.4. And if this is to be converted to binomial, I mean normal distribution, X belongs to normal distribution, and for normal distributions our parameters are mean is n into P. Okay, so this is our n, this is n, this is our P. So first parameter is mean. If we multiply 80 by 0.6, it is going to be 48, and our second parameter is the variance. Variance is the multiplication of product of NPQ. 48 into zero point 0.4, if it is multiplied, it is going to be 19.2. 19.2 is our variance. This is NP. This first variance, first parameter is NP, and second parameter is N multiplied by P multiplied by Q. Then let's start our solution. Our solution is probability of X. Use a suitable approximation to find the probability that more than 50. Look at this, more than 50. So X is greater than 50 means if we apply continuity correction, then it is going to be 50.5. It is continuity correction. Please don't get confused with this continuity correction. So continuity correction, because it is more than 50, that means if we apply the continuity correction concept, then it is 50.5. Now we are going to standardize the score. Probability of Z greater than 50.5 minus our mean. What is our mean value? Our mean value is 48. 48 over standard deviation. Standard deviation is the square root of variance, which is 19.2. Okay, then using our calculator we are going to get Z greater than, it must be positive, it is going to 50.5 minus 4.8. Z is greater than 0.5705, 0.5705. This is our Z score. Now if we draw a normal distribution graph, then we can be clarified. This is our curve. Okay, so here then the midpoint is 0 and our z score is positive. So suppose it falls over here 0.5, 0.5 or 0.57 something. So which part is our probability? Our probability is this tiny parts. Okay, this dark part, this black part is our probability, and we know that for tiny probability what we can do, we will find the whole of the probability from which we will subtract the larger part. So this is our larger part. If we subtract this larger part from whole of the graph, whole means one whole probability, the probability of whole region is 1, from 1 if we subtract this red part, left side or red part, then we will get our tiny part. So always whenever we require tiny probability of tiny region, then we will subtract the larger part from 1. Okay, so let us see what is the probability, corresponding probability when z score is 0.5. Before moving on to that, let us write it is from 1, we will subtract the left part. So probability when z is less than 0.5705. Okay, so our z score is 0.5705. Let's see what is the corresponding probability. 0.5705. So first of all, our row is 0.57. I mean 0.5. 0.5. 0.5 is over here. The column is, first row is 0.5. Then 7, first column is 7. So first column is 7. Then the final column is 0.57. Then we require actually 0. Okay, so as there is no 0, so 0.571, it will be 0.57. As it is 0.571, we can take 1. Okay, if we round it up to 3 significant figures. So our probability, first this is the row, this is column, and then we will add up these 3. Okay, so if we add up 0.7157, if it is added to 3, so our probability is, corresponding probability is 0.71. 57 plus 3 means 60, so it is 0.716. 0.716 is our corresponding probability. So let us write our corresponding probability for this z score was 0.716. 0.716. After that, if we do subtraction from 1, it is going to be 0.284. 0.284. That is what our approximate value of this normal distribution. And that's how we can solve the question based on approximation from binomial to normal distribution. You can solve this, and I tried my level best to explain every tiny part from each of the questions. And if still there is any confusion and you require that clarification, please let me know through WhatsApp. I will try my level best to remove the complication and difficulty you are facing in solving any of the mechanics one question or probability and statistics one question, and not only mechanic and probability one. It means from paper 1 2 3 4, paper 1 2 3 4 5, any of the papers. If you face any difficulty, please let me know through WhatsApp, and then I will solve that for the benefit of all of the students. Fi amanillah. Now we are going to discuss about geometric distribution, and for solving the practical questions on geometric distribution, I have chosen paper 9709/51 for the session May June 25 to be the first question for solution, and we have chosen question number 2 for solving geometric distribution based questions. Okay, so let's see question number 2. Question number A of this question doesn't belong to geometric distribution, that's why we are skipping that one. Let's move on to question number 2B. Before we start writing the solution, we should know which distributions are called geometric distribution. Look, geometric distribution is primarily a distribution when the desired outcome is obtained, then experiment is over. That means experiment keeps on going on and on and on until we obtain the desired outcome. So it is actually, there is no certain number of experiment is uncertain, but probability, individual probability for every trial or every experiment is fixed. And usually the question contains the words either until or first. Whenever you find one of the words until or first time, then we will directly understand that this is a geometric distribution. So simply, geometric distribution, definition of geometric distribution is an experiment will be kept onward until we obtain our desired outcome. Let's see the first question, question number B from 2 of this paper. Let's read question number B. A fair 8-sided dice has faces labeled KANGAROO. The dice is rolled repeatedly. Find the probability that fewer than 6 rolls of this dice are required to obtain an A. So the dice was kept rolling on until we obtain an A. That means this is a geometric distribution, and it is the dice was rolled less than 6 times. So let us start our solution. We can start our question belongs to geometric distribution, and for geometric distribution parameter is nothing but the probability. Look at this. We our desired outcome is A. So how many A's are there? There are 2 A's out of 8. That means 2 over 8 is our probability, which is 1 over 4. So 1 over 4 is the probability of obtaining an A. That means our P is 1 over 4, whereas our Q, that means probability of not obtaining an A, is 3 over 4. Q is equal to 3 over 4. Well, then let us solve. They have told that it will be probability of, now we are going to find the probability x is less than fewer than 6 rolls. Okay, so x is less than 6 rolls means, what does it mean? It might be obtained among first 5 rolls. Less than 6 rolls means it was rolled for 5 times, and among these 5 times somewhere there was success. And the formula for this equal or less than a number is 1 minus. So out of 5 times, every time there was all times, all 4, 6 attempts were not failed. All 5 attempts were not failed. Somewhere there was success. So we will just subtract the probability of not obtaining A is 3 over 4. 3 over 4 raised to how many times? 5 times. It was rolled 5 times, and among these 5 times there was one success. And the formula of this is, let me show you the formula. Formula is going to be probability of x less than, suppose this is r, okay, is equal to 1 minus q raised to r. Q is the probability of not obtaining the desired outcome every time. So finally our result is going to be 1 minus 0.755 times. It is equal to 0.673, and that's our answer. Let's read the immediate next question. The immediate next question says that find the probability that the second A is obtained on the 6th roll. So this is a little bit different actually. There are total 6th roll. Okay, so 1, 2, 3, 4, 5, 6. Among these six rolls, there were, one thing is sure, that on the 6th roll there was nothing but success. Look at this. This is second A. So A was obtained for the second time on the 6th roll. But what about the first, 5th? Because we should not deviate from the question. Whenever outcome, desired outcome is obtained, then rolling is over. So this is for the second A. Second A, and it was obtained on 6th roll. That means on the 6th roll there was nothing but success. So on the 6th roll we have obtained an A, but among the first 5 rollings there is no certainty of success. We succeeded once among these five, but we don't know what is the exact number of roll when we got succeeded. So this is somewhat a binomial distribution, and the final one is nothing but success. So let us write here probability of second A on sixth roll, on sixth roll or turn, sixth roll is equal to, so on the sixth trial we got success, and the probability of success is 1/4. But among previous five trials we don't know the number of exact success, but there is only one success among the first five. So among five there is one success. Five choose one success. The probability of being succeeded is 1/4, and probability of failing, that means rest four times we failed, so it is 3/4. So once we succeeded and four times we failed, it is 4. Let's simplify this more. If we simplify it more, it is going to be uh, 5 choose 1 is actually 5. 5 will multiply 1/4. How many 1/4s are there? 1/4 is 2 times. So 1/4, 1/4, 2 times, 2 successes and 3 failures. Not 3, 4 failures. So 3/4 total there were 6 attempts, and out of this sixth attempt, 2 times we succeeded and 4 times we failed. So finally our probability is going to be 5 into 1/4 squared into 3 raised to 4. It's equal to 0.0989 is our probability, desired probability, and that is the final answer. I think you got the clarification of geometric distribution. Let's solve the next question from paper 52, question number 4 BC. The next question has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 4, which says vehicles approaching a certain road junction from Bromley must go either left, right, or straight on. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. The driver of each vehicle chooses a direction independently of all other drivers. So this is actually whether this is geometric or binomial, not specified. If we go through question number B, then we can see that this belongs to geometric distribution. Let us see what B says. B says find the probability that from the vehicles approaching this junction from Bromley today, the first vehicle, look at this, the word, I think you remember initially I have written if the word first or until is mentioned in the question, that belongs to geometric distribution, and it contains the first vehicle. Okay, so for this word it belongs to geometric distribution. Which goes left is before the ninth vehicle, somewhat similar to the previous question. So let us start our solution. X belongs to geometric distribution, and for geometric distributions our parameters is the probability, only probability. Let's see in the left what is the probability of turning to left. 30%, look, 30% turn left, so it is 0.30 is our probability. 0.30 is our p. Okay, so our p is equal to 0.30. Hence our q is going to be, how much is q? Rest of the probability is 0.30. 0.70 is not turning to left. Well, then let's solve the question. The question tell probability of, they have told us to find before ninth vehicle. Look at this, before ninth vehicle. So x is less than or equal to 8. That means before 9 means 9 must not be included before 9. But among before 9, I mean among first 8 trials or experiments, we don't know when the first vehicle turned to left. That's why we will solve it. The formula is, as I have written in the previous solution, formula is 1 minus q raised to r. Q is our zero point 0.7, so 0.70, how many times? 8 times. I think you have got my points, that among the first 8 turns, we don't know when a car or a vehicle turned to left. That's why in all 8 turns there is no failure, there is one success, but we don't know. That's why the formula is 1 minus q raised to r. And if we simplify this, it is going to be 0.942. 0.942 is the final answer. Then let's see the immediate next question, which says find the probability that from the vehicles approaching this junction from Bromley today, the second vehicle to go to left is the 7th vehicle. So this is also somewhat similar to the previous question. Let us write here probability of, look at this, second vehicle to the left on which trial? On the 7th trial. Second vehicle to the left on 7th trial or 7th experiment. That means 7th vehicle turned to the left for the second time. This is the second vehicle actually. So what is our formula? That means on the second, if I draw a scenario, look, there are 7 trial. 1, 2, 3, 4, 5, 6, 7. On the 7th turn, there was nothing but left. 7th vehicle turned left. This is sure. Okay, so we can apply this one, that 7th turn, our probability is 0.30. So on the 7th trial there was nothing but success. Now among the previous 6 turns, these 6 turns, we don't know when a vehicle turned left. That's why we will have to use here 6 choose among 6. 6 choose among 6, there is only one vehicle who turned left, so there is only one left, and the probability of turning to other direction is 0.7. that means q 0.7. But how many vehicles? Among 6, 5 vehicles turn to the other directions. So if we simplify it more, it is going to be 6 choose 1 is 6, and how many 0.3 are there? 0.3 2 times, because there were 2 vehicles turning left 2 times, and 0.70, the rest of the 5 vehicles out of 7, rest of the 5 turn to the other direction. And if we use our calculator, our probability is going to be 6. Then if we round it up to the 3 significant figures, it is going to be 0.0908. 0.0908 is our final answer. Let's see the next question. The next question belongs to paper 9709/53 for the session May June 25, and we are going to solve question number 3, all of them from 3. Let's see what the question says. a fair six-sided dice with faces labeled 1 until 6 is thrown repeatedly until A3 is obtained. Look at this. Until is the clue word of this question. That's why we can decide that this belongs to geometric distribution. The number of throws taken is denoted by the random variable x. And they have told to find when there were 8 throws to obtain A3. So we can start writing x belongs to geometric distribution whose parameter is 1 as this is fair, so for obtaining a 3 there is 1 over 6 our probability. Okay, so if p is 1 over 6, then q is going to be surely 5 over 6, 5 over 6. Okay, then they have told us to find that 8 rolling or 8 spinned where it was thrown, 8 throws were required to obtain A3. So we can write probability of x, that means 8 throws. So among 8 throws, it means on the 8th throw it was success, so which is 1 over 6. And among the previous 7 throws, all of them were failed. So the probability of failing in each of the throw is 5 over 6, but we failed 7 times back to back for obtaining A3. I think you have understood my point. That means we got succeeded once and previous 7 times it was absolute failure. So the answer is going to be 1 over 6 into 5 over 7 raised to 7 times equal to 0.0465. 0.0465 if we round it up to 3 significant figures. Well, then let's move on to the next question. It says find the probability when it was thrown x less than 9. So it is equal to probability x less than 9. What does it mean? It means actually we obtained A3 on 8th throw or before that. That means less than 9, one thing is sure, on the 9th throw, 9 throws were not required, but 8 throws were required. Among these 8 throws, there was 1 success and 7 failure. But as we don't know when we got succeeded, so we will have to write the formula we know is probability of, I am just writing this for reminding you of the formula. X is less than suppose r times, okay, equal to 1 minus q raised to r. Okay, so simply we are going to apply the same concept. 1 minus so the q, our q is 5 over 6. 5 over 6 how many times? 8 times. 8 times. That means among these 8 times, somewhere we got succeeded, but the number of throw is not known to us. That's why we apply this formula. Then finally our result is going to 0.6. So our final answer is going to be 1 minus 5 over 6 raised to 8 is 0.767. 0.767, which is our final answer. Okay, let's see what the immediate next question says. The immediate next one says, find the probability that A3 is obtained for the second time before the 6th throw. Yes, this is a twisted question, and remember, this is absolutely different from all of the previous solutions. If we analyze the scenario 1, 2, 3, 4, 5, 6, 7, 8. Among these 8 throws, actually, no one has been certain. It's absolutely uncertain. Look at this. Neither for the first one nor the second one. In the previous solutions, one of the solutions we have done that at least the second one was fixed. Second success was fixed at the 7th or 8th trial. or fifth or fourth trial. That means it was the total number of trial was given, and the finally it was written that the final trial was nothing but success. But here look at this, even the neither the second one nor the first one for the second time before the sixth throw. That means second one is not also certain. There are many possibilities of this. That's why it should be done in a different way. So once again, I am requesting you, don't get confused. In the previous ones, actually it was told that second success was obtained on a particular throw. It might be seventh throw, there was second success, or eighth throw, there was second success. But here there is no particular number of throws, neither for the first success nor for the second success. So we'll have to analyze the scenarios gradually. So let us start our writing. Probability is equal to probability of, if we write it, it is going to be second A. Second A. Second A on or before sixth throw is equal to, it might be, we'll have to calculate the probabilities individually. So what are the possible cases? He might be succeeded in the first two cases. So first throw there was success, and in the second throw also there was success. Okay. Or there were three throws. Among the three throws, third throw was definitely success. Third throw is success. But between the first two throws, there was one success, one fail. One success as well as one fail. It is 5/6. Okay, I think you are getting my point, that if we assume that uh, three throws were required, among these three throws third throws was success, that's why 1/6. But between the previous two throws there was one success and one failure, that's why we have written 2 choose 1 multiplied by one success and one failure. Okay, let's consider if there were four throws. So among four throws, fourth throw was success. Fourth throw was success, not 1/4, 1/6. 1/6, that means fourth one is success. But among the first three trials, three experiments, there was only one success and two failures. So one success, and probability of failing is 5/6. 5/6, how many times? Two failures. So this is the probability when we assume that he succeeded for obtaining second A on the fourth trial or fourth experiment. Then he might get succeeded on fifth trial. On fifth experiment, it was nothing but success. But among the previous four trials or four throws, there was one success, three failures. One success and three failures into three. Out of three, there was one success, and out of four, there was one success and three failures. So probability of failing is 5/6, and he failed three times. So these are the all possible cases. Look at this. We cannot include sixth time because they have written that before sixth. Look at this. Before sixth throw, the second A was obtained. So before sixth means actually until five throws. It required five throws to obtain A for the second time. But it is not particular or certain that on the fifth throw there was success or not. I think you got my point. If I recap this, actually, the concept is they have told before sixth throw there was second A obtained, but they didn't mention whether on the sixth throw they obtained second A. Sixth throw is not fixed. I mean, fifth throw. Before sixth throw means fifth throw. So here we will have to rectify. It cannot be on or before. It is actually before. Okay, it is not on or before because they have told before sixth throw, so on cannot be included here. It's a wrong concept. Before sixth throw, so before sixth throw means there were five throws. Among these five throws he might be succeeded in the first two cases, or he might be succeeded for three trials, and he might be succeeded on four trials, or on fifth trial he got succeeded. So among all of these cases, one is particular success and rest of them were failed, for which we have applied the binomial theorem. So let us simplify this. 1 over 6 squared plus, here 2 choose 1 is 2, so 2 into 1 over 6, 1 over 6 two times. Actually every cases there were two a's, so success were two times, and 5 over 6, 5 over 6 was once, and again 3 choose 1 is 2, and success definitely two times because two times we obtained A, and rest two times we failed. So 5 over 6 two times, and here also 4 choose 1 is, let me zoom it out, 4 choose 1. Okay, 4 choose 1 means 4. So if we can write 4 into 2 successes, so 1 over 6 two times, and how many times failure? Failure occurred three times. 5 over 6 three times failure, two times success. I think you got my point. So you cannot compare this solution to any of the previous solutions because this is absolutely an exceptional question, twisted question. So please don't get confused. Simply you can think that he might get succeeded in the first two trial, or among three trials third one was success, first two were failure. Third one success, and between first two one was success, one was failure, but we don't know which one was success or failure. That's why we have applied the concept of combination, two choose one. Then in the third case there were total four throws. Out of four throws, here I am talking about this one, here there were four throws. Out of four throws, fourth throw was nothing but success. So for fourth throw it was 1 over 6, but among previous three throws there was one success, two failure, but we are not certain about the number of trial when we got succeeded. That's why among three there is one success, two failure. Thus we kept on doing till the fifth trial. Then finally our result is going to be, if we use our calculator, it will show that our probability is 0.1962. That means 0.196 if we round it up to three significant figures. And that's all about the topic of geometric distribution for the session May June 25. And I believe that the third one is a little twisted, but I tried my level best to clarify this. So let's move on to the next topic of probability and distribution. There lies a mistake over here. Actually 3 choose 1, 3 choose 1 is 3. It should be 3, not 2. So 3 times 1 over 6 squared into 5 over 6 squared. Thank you all for being with me. Let's move on to the next topic. Now our topic is permutation and combination. And the first question I have selected is from paper 9709/51 for the session May June 25. And we are going to solve question number 2. Let's read what question number 2 says. It says, find the number of different arrangements of the 8 letters in the word kangaroo in which the two A's are together and the two O's are not together. Well, so initially we are sure that the concept is arrangement. For arrangement, we always apply the concept of permutation. That means this question will be solved applying the concept of permutation. So let's start writing the scenario. Total, there are two A's. Okay, sorry, four A's. There are four A's and two O's. These are the two O's and then four A's. Okay, and the condition is restriction is there will be two A's are together. Okay, and the two O's are not together. Sorry, there are only two A's, one A as well as another A's. So let us write the scenario. 1, 2, 3, 4. If two A's and two O's go away, there remains only six others letters, different letters. So 1, 2, 3, 4, 5, 6. Among these six, A should be together. Let it be over here. Here, A's, both the A's will be together. Okay. And then O's will be either, look at this, as A's are together, there cannot be anything in between them, so let it be one box. So how many ways are there? 1, 2, 3, 4, 5. So number of arrangements is equal to, so there are 5 units. Now they can interchange their position in 5 factorial ways. Okay, now what about the remaining letters? I mean the O's. Okay, the O's, O may be over here, one O, because they cannot be together. These are the places for O to be placed, or here or here. So these are the places of O, and this is also it can be over here also. Okay, they didn't mention that A should be at the beginning. They told A will be together with each other, but they can be placed anywhere. So how many places are left for O's? 1, 2, 3, 4, 5, 6. There are 6 places which are applicable for to be O's. So out of 6 places, as there are only 2 O's, they will occupy 2 places. Okay, but we have not forgotten that these two O's are identical. As 2 O's are identical, we will have to divide it by 2 factorial ways. Okay, I think you know that for identical letters, for number of identical letters, it should divide the total number of arrangements. So what is it going to be? If I write over here, let me write just below this, equal to 5 factorial means 120. Okay, and 6 factorial 2, I mean 6p2 is actually 6 factorial over 4 factorial. That means you will have to subtract the chosen one, I mean this 2, and then this 2 factorial, this must be denominator. So what is it going to be if we use our calculator? 120 into 126 factorial is also 120, divided by 4 factorial means 24, then 48. So let it be calculated. If we use our calculator, it is going to be 1800. 1800. So this is the number of arrangements with the given restrictions. Yes, that's is the whole of the solution to the question number A. So what have we learned from this question? We have learned that for arrangements we apply always permutation concept, and for identical letters always we will divide the total number of arrangements by the number of identical letters or objects, and thus we have got this. And don't get confused that for O, O's can be placed in between any of these places. Total there are 6 places, out of which they will occupy only 2 places. That's why we have written 6 permutation 2, and then as both of them are identical, that's why we will have divided by 2. Let's see the next question. The next question under the same topic has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 6. Find the number of different ways in which the 10 letters in the word amalgamate can be arranged so that there is an M at the beginning, an M at the end, and no A's are together. Okay, so let us write. Total there are 10 letters. Okay, among these 10 letters, if 2 M's and 4 A's, there are 4 A's. If 4 A's and 2 M's go away, there remains only 4 other letters. So let us write the first one is M. And before I start the scenario, let me erase this. If 4 A's are excluded, then there will be 6 more places. So 1, 2, 3, 4, 5, 6. Among these 6, it is restricted that first the word should be started with M and it should end with M. Now, how many letters are there in between them? There are 1, 2, 3, 4 letters in between them. Well, now about this 4 A's. These 4 A's will be placed either over here. I think we can show it later on. Let us start our writing. Number of arrangements. We know that for arrangements always we apply the concept of the permutation. Number of arrangements is equal to, so how many letters are there? 1, 2, 3, 4. 4 letters. Okay, so 4 letters can be arranged in 4 factorial ways, and there is no other identical letters. That's why there is no necessity of dividing this quantity. Well, now about the M's are identical, so there is no question of arranging M for identical letters. Combine, if all of the letters or objects are identical, then permutation and combination standard formula is not applicable. I am going to clarify this in the next question. Well, so for M there is no question. Now all of the A's, A can be over here or there, 2, 3, 4, or this 5. So these A's can be placed among these 5 places. So out of 5 places, 4 A's will occupy 4 places, and we are not unaware that A's are identical. For number of identical letters, always we divide it by the number of letters. So what is it going to be? Finally 4 factorial, and 5p4 is actually 5. Okay, 5. And if it is divided by 4 factorial, 4 factorial means actually 24. So finally our number of arrangements is going to be, remember before I end up, I want to clarify the question. You may tell that why didn't we use this position? Okay, this position before and after. Look, we should not get deviated from the question. The question told that M must be at the beginning as well as at the end. So before and after M there should not be, before the first M and after the last M there should not be any other digits. That's why this is not applicable. So these are the only 5 places among which the 4 A's can occupy and they can sit. So if we do our calculation, 4 factorial 24, 124, sorry, 5 p4 means 5 factorial. It is not 5c4 is for combination, 5c4 is 5, but 5p4 is for permutation, it is 5 factorial. So 4 factorial and 24 are actually same, so 5 factorial is our answer. and 5 factorial means 120. So there are 120 ways to get them arranged. So there are total 120 ways to arrange them. Let's see what the immediate next question says. The next question says, find the number of different ways in which the 10 letters in the word amalgamate can be arranged with exactly 3 letters between the two M's. So let us write the scenario. The scenario is 1, 1, 2, 3, 4, 5. That means between the M's there will be 3 letters. Well, so if 3 letters and M's goes 5 went away, there remains 5 more. So 1, 2, 3, 4, 5. Then let us write number of arrangements. Also the permutation formula, number of arrangements is equal to, okay, so if M's go away, how many places are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 factorial ways to get them arranged. Among these 8 letters, actually there are 4 A's. So these 4 A's we will divide by 4 factorial ways. Then for the next cases, what is the next case? Look at this. If we suppose that this is 1 unit, then how many places they can interchange? This M already there is one place it has occupied. It can be, this box can be shifted over here, or this box can be shifted over here, there as well as here. So how many places they can shift themselves? Already it is one place. Suppose already they are in one place and they can shift here 1, 2, 3, 4, 5, 6. They can shift themselves in 6 ways. So here there is a huge possibility of getting confused, that you may think that they can interchange their position in 6 ways. No, actually this is not interchange their position. This is not 6 factorial ways. This is only 6 ways, because as they have already been in one box, they cannot interchange in 6 ways. They can only change their position in 6 ways, not 6 factorial ways. Please don't get confused. It is not factorial. This is actually 6 ways, as there is a restriction that between M there should be 3 letters. So they cannot actually, their other letters have already been arranged, as they have already been fixed between M's. So there is no other scope of getting arranged again. They have already been arranged. Now only for this box they can move to the right or left in 6 ways, not 6 different ways. So if we calculate this, we will get total number of arrangement is going to be 10080. 10080. So please don't get confused with this question. It is not 6 factorial. This is 6 ways, because there is restriction among the M. The letters cannot. The letters have already been arranged. So again they should not be arranged. The box can be shifted or moved to the right onward in 6 ways. Then let's see the next question. Question number C says 5 letters are selected from the 10 letters in the word amalgamate. Find the number of different selections. Look at this. This is selection. For selections, we don't apply permutation concept. We apply combination concept, in which 5 letters include at least one M and at least 2 A's. So let us see the scenarios. 2 A's. Total there are 4 A's. So let us write 4 A's. 4 A's, and there are 2 O's. Sorry, 4 A's and 2 M's. 2 M's. I think M has been mentioned first, so we should write M first. 2 M's. There are 4 A's and 4 plus 2, if 6 go away, there remains 4 others. 4 others later. Okay, so from 2m's, they have told us to choose at least one. So let us choose one, only one. So 1m we are choosing in the first case 1m, and at least they have told to choose 2a's. So let us choose 2a's. Then if we choose 1 plus 2, they told the total number of letters will be 5. So we can choose 2 more letters from the remaining ones. Then in the second case, let us choose again at least one. We are starting with this at least one, and from here we can choose 3a's. Then we can choose one from the remaining ones. Let us choose again one letters, and as we can choose maximum 4a's, then there remains nothing to be chosen from the remaining ones. In the fourth case, we can choose, let us choose 2m's, both the m's, and from here also 2a's, and then we can choose maximum 1 from the remaining ones. After that, the final case, let us choose again 2m's and 3a's. If we have already chosen 5 letters, so there is nothing to be chosen from the remaining ones. So these are the possible cases. We cannot take more. There is no more m's left we can take. If we choose 3, which is not, there are only 2 m's, so we cannot choose 3 m's. So these are the possible cases, and here also we have chosen maximum 4 a's have already been chosen. Well, now the concept is actually, look here, if we choose 1m from 2m's, actually number of ways is 1. So let us learn something, that let me write just above this. Permutation and combination concept is applicable for distinguished and different objects. So this is the concept. We should not get deviated from this. Actually, standard permutation and combination concepts are applicable for distinguished objects. The objects should be different from each other. That means if all of them are identical, then neither permutation nor combination formula is applicable. That's why here, if all the objects are identical or similar or same, then this concept is not applicable. But among many, if few of them are identical, then it is applicable. If we analyze our m's and a's, look at this, all the m's are identical here and all the a's are identical. So here actually combination concept is not applicable. That means the whatever the number of selection, it will be actually one. How many of them are do you select, it will be only one ways, because the objects are identical. You cannot distinguish and different them from each other. That's why number of selections or number of arrangements from all identical objects is always 1. So this one is m is, for m it is always 1, for a is also it is always 1. So these two can be avoided. We can easily avoid this. In each cases the number of selection will be 1 because all of them are identical, but these are the different and distinguished objects. So from 4 we will have to choose 2. Let us write equal to 4 choose 2. 4 choose 2 is actually 4 factorial over 2 factorial as well as 2 factorial. Then it is going to be the next one. From 4 we are choosing only 1. Okay, so 4 choose 1 is actually 4. Then we are choosing nothing from 4 objects, so that is only, there is only one way to choose nothing from 4. Then the next case, from 4 we are choosing 1. So if we choose only 1 from 4, there are 4 ways to select them. Then if we choose 0, that means no one from 4, there is also one way to choose. So this is what the total number of selections. Let us write total number of selections here. So if we find the number of arrangements, it is 4 factorial means 24. If 24 is divided by 4, it is 6. Then 4 choose 1 is 4. Then 4 choose 0 is 1. If we choose nothing from 4, there is only one way, and 4 choose 1 is 4. 4 choose 0 is 1. So total number of selection is going to be equal to 4 plus 1 5, 5 plus 1 6, 6 4, 10, 10 6, 16. So there are 16 ways to select the letters as per the restriction. So from this question, what have we learned? We have learned that for if all the letters or objects are identical, then the standard combination and permutation formula is not applicable. Permutation and combination formula is applicable when the objects are different of same category. Category may be same, but the object should be different from each other so that they can be distinguished easily. So I think you have learned this twist. And then let's see what the immediate next question we are going to solve. The next question has been selected from paper 9709/53 for the session May June 25, and we are going to solve question number 7, which belongs to the aforementioned topic. It says a set of friends consists of 7 men and 4 women. 3 of the men are brothers Ali, Ben, and Charlie. Find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. So let's start our solution. So since the concept is about arrangements, we are going to apply the concept of permutation. Okay, so for permutation, first of all, let's see, they told that Ali and Ben, they should be accepted. If we avoid Ali and Ben, there remains 5 more people because there were 7 men. Out of 7, Ali, if Ali and Ben are excluded, then there will remain 5 remaining men. So we can write number of arrangements, number of arrangements is equal to 5 people can be arranged in 5 factorial ways. Okay, then I think it's better I should show you the scenario. The scenario is if 2 goes away, out of 7 there remains only 5. So 1, let me show 1 2 3 4 5. Okay, then remaining, this is the for the 5 people. Okay, now about Ali and Ben, what happens? Ali and Ben, they can be, Ali can be over, Ali and Ben, they can occupy any of these 2 places, any of these 2 places. Okay, so how many places are there available for them? 1 2 3 4 5 6. Out of 6, they will occupy only 2 places, so 6 p 2. Hence, it is going to be 5 factorial. Numerator is going to be 5 factorial into 6 factorial. And our denominator is going to be 2 factorial as well as 4 factorial. Finally, our number of arrangements is going to be 3600. 3600. This is the number of arrangements with the restriction given. Sorry, I made a great mistake. It should not be 2 factorial. It will be only 4 factorial. This is not combination. We are applying the permutation concept. And 5 factorial means 720. 4 factorial means 24. So 24, if 24 divides 120, that is 5. Okay, 120 divided by 24 is 5, and if 5 multiplies 6 factorial means 720. So 725 times is equal to 3600. Let's see the next question. The next question says Find the number of different arrangements of the 7 men and 4 women in a line in which all the men stand together and all the women stand together. So what will be the scenario? There are 7 men, okay? 7 men on one side and 4 women on the other side. 4 women on the other side. So 7 men can be arranged in 7 factorial ways. We can easily write number of arrangements for the men. There are 7 fact, they are definitely different from each other. So 7 factorial ways they can be arranged, and 4 factorial ways the women can also be arranged. Now there is one more point to be noted, which is, look, women can be, this all 7 is on the left side, okay, and this all 4 is on the right side. They may interchange their positions in 2 ways, okay, in 2 ways. Men may stand later on and women may stand at the beginning. So there are 2 possible cases of interchanging their position. So we will have to multiply by 2. So 7 factorial divided 7 factorial into 4 factorial into 2 is 241920. It is going to be 241920. 241920 is the number of arrangements. Okay. Let's see what C says. C is on the next page. It says that in how many ways can the 7 men and 4 women be divided into a group of 6, group of 3 and a group of 2. Okay, so there are 3 groups. The first group contains 6, that is 6 people in the first team, then 3 people in the second team and 2 people in the third team. And they have told there are no restrictions. Okay, so simply we can write, and for select, look at this is the how many ways they can be divided, means selected. It is selection, remember, it is not arrangement. Just we will find number of ways they can be selected or divided. So we will write, for selection we apply the concept of combination. So total initially there are 11 people. Out of 11 we are choosing only 6. Okay, then there remains only 5 people. Out of 5 we are going to choose 3 for the second team, and there remains only 2 people left, out of which we will choose 2 for the final team. Then equal to, it is going to be, our numerator is going to be what, 11 factorial, 11 factorial into 5 factorial into 2 factorial. Well, then denominator is going to be 6 factorial, 5 factorial. 6 factorial into 5 factorial for the first case, first team, and the second team is 3 factorial as well as 2 factorial. Then finally it is actually 2 factorial and 0 factorial. So these 2 factorial can cancel each other, and 11 factorial into 5 factorial over 6 factorial, 5 factorial and 3 factorial, 2 factorial. Number of selections, now we can write, hence number of selection is equal to selections is equal to, if we use our calculator, it will show there are 4620 ways of arranging or selecting or dividing them into 3 different groups of 6 people, 3 people and 2 people respectively, and there is no other restriction. So simply we can apply the concept of combination. That's all about C. Let's see question number D. Question number D is on the next page. No, not on the next page, just below this, which says the 7 men and 4 women are divided at random into a group of 6 3 and group of 2. Find the probability that Ali, Ben, and Charlie are in all the same groups. So for the first group, it was, what was it? For the first group, there were 6 men, 6 people. Among six, it is 6. Okay, and for the second group, there were 3 people chosen, and for the final group, there were 2 people chosen. So among six, if we choose 3 people, let's assume that Ali, Ben, and Charlie, three brothers, are in the first group. So A, B, C are in the first group. So there are 3 more left to be chosen. Total 6. And here there are 3 to be chosen from the remaining one and 2 from the remaining ones. And the second case, let's see, in the first group, Ali, Ben, and Charlie are not in the first group. So 1, 2, 3, 4, 5, 6. They are in the second group. Okay. So A, B, as well as C. Ali, Ben, and Charlie, they are in the group of 3 people. Then next 2 should be chosen. Now you may think of the third option, that Ali, Ben, and Charlie, they can be on the in the third group, which is not possible at all. Remember, in the final group, third group, there are only 2 people, but Ali, Ben, and Charlie, they are 3 brothers. So as there is no scope of placing 3 people in the final group, so there is no other option left. So we will have to write these one first. Total there are 11. Out of 11, we will choose just these 3 for the first team. So the first possibility is number of choice. Total there were 11. Okay. Um, Out of 11, Ali, Ben, and Charlie, who have already been selected for the first team, so there remains only 8. So out of 8, we are choosing only 3 for the first group. Then there remains only 5 people left. So out of 5, we are going to choose 3 for the second team. Then there remains only 2 left, which will be chosen for the final team. And in the second case, look at this, all 6 should be chosen from 8 people, because Ali, Ben, and Charlie, they have already fixed in the second team. Here they have already been fixed. So the first 3 people cannot be included here. Remember, if someone is already selected, that cannot be selected again. So already these 3 have been selected. There remains 8. Out of 8, for the first team, we will choose 6. So it is 8 choose 6. 8 choose 6. Then for the second group, actually all 3 have already been selected. So it is 3 choose 3. Then there remains only 2. For 2, we are going to choose 2 people. So it is going to be 8. So the numerator is going to be 8 factorial into 5 factorial. 2 factorial, 2 choose 2 is actually 1. So which can be ignored easily. If we ignore this, then it is going to be, numerator is 3 factorial into 5 factorial for the first case. And for the second case, 3 factorial into 2 factorial. 3 factorial into 2 factorial. Okay. Then for the second case, numerator is 8 factorial into 3 factorial. 8 factorial into 3 factorial. Denominator is 6 factorial into 2 factorial. 6 factorial into 2 factorial. 2 factorial. Then for the second, uh, here we can erase this 3, because 3 factorial, 3 choose 3 is actually 1. So let us reduce the bulk of calculation. So it is 8 factorial over 6 factorial into 2 factorial. Finally, if we use our calculator, it will show that there are 8 factorial into 5 factorial over 3 factorial, means 6 into 120 into 6 into 2. So it is 560 ways. 560 ways it can be chosen. And finally 8 factorial over 720 into 2, so 1440. 8 factorial over 1440 is only 28. 28. 8. So now number of selections with restrictions, number of selections with restriction can remain invisible. So 588. Okay, look, we should not deviate from the question. The question told to find as the probability. So probability is equal to, we can easily write here, probability is equal to probability is equal to, you know how to find the probability. This is the total number of selection with restriction, and without restriction the number of selection we have done here, it is 4620. This is the number of selections without restriction, and this is the number of selections with restriction. So easily we can find the probability dividing 588 by 4620 equal to, if we divide using our calculator, it will show that it is 0.127. So that is what the final probability is, and I believe that you have understood every tiny part of this solution. That's all about this question. Now we are going to solve one more question from paper 55. Okay. The immediate next question has been chosen from paper 9709/55 for the session May June 24, and we are solving question number 6. It says a darts club has 12 members made up of 7 men and 5 women. Every Monday, a team of 4 is chosen at random to represent the club in a competition. Find the probability that on a particular Monday, the team consists of 1 man and 3 women. So, let us write, first of all, 4 men should be chosen randomly, and that means without restriction. So, let us write number of selections without restriction. Number of selections without restrictions. Without restrictions. Then we will write number of selections with restrictions. Number of selections with restrictions. Selections with restrictions. Restrictions. Okay, equal to. Now let's see, if there is no restrictions, there are 12 people. Out of 12 we are going to choose only 4. So it is 12 choose 4. Well, then it can be written as 12 factorial over 12 factorial over 4 factorial, as well as 4. Let me change the ink. So number of selection without restriction, there were total people. Out of total we are going to choose only 4 randomly. Okay, if we do so, then it is 12 factorial over 4 factorial, as well as 4 factorial into 4 factorial into 8 factorial, and the number of ways is going to be, if we divide 12 factorial by 4 factorial and 8 factorial, it is going to be 495 ways. So 495 ways we can choose the number of people without any restrictions. Then with restrictions, with restriction is, they have told that there will be 1 man and 3 women. So 1 man out of how many? Out of 7, now there is 1. So 7 choose 1. And from men there were 5 women. Out of 5 we are going to choose 3. Okay, 5 choose 3. 5 choose 3. Hence it is 7 choose 1 is actually 7. You know, 7 factorial divided by 6 factorial means actually 7. And 7 factorial into 5 factorial means 7 into 5 factorial. And then 3 factorial into 2 factorial. Finally, it is going to be, if we use our calculator, it will show that it is 7 into 5 factorial over 3 factorial into 2 factorial. It is number of ways is 70. So look, the question told us to find the probability. So we are going to write probability is equal to, hence probability is equal to, let me write over here, hence probability is equal to probability is equal to, what will we do? We will just divide this 70 by the total number of selection without any restriction. This 495, 70 will be divided by 495, and finally our answer is going to be 70 divided by 495, it is 0.141. So 0.141, let me write over here. So if we divide 70 by 495, our probability is going to be 0.141. Then the immediate next question, question number B says, every Tuesday the dart club chooses 3 teams of 4 each men. Each team enters a competition in a different towns. In how many different ways can the team be chosen if there are no restrictions? So without restrictions we can simply write them. There are 3 groups actually. There are 3 groups. So for each group contains 4. So initially 4 people. First, if we choose number of choice, number of selections, definitely we are going to apply the concept of combination is equal to, not there, let me write just beside this. So first there are total 5 people. Out of 5 we have chosen 4. Then there remains 8. Out of 8 we are choosing the second 4, and there are remaining 4 people will be chosen for the third group. Then our probability, I mean number of selection, is going to be, numerator is 12 factorial into 8 factorial, and 4 choose 4. If you choose 4 people, for among 4 people there is only one way to choose all of them. So denominator is going to be 4 factorial into 8 factorial into 4 factorial into 4 factorial into 4 factorial, and finally the number of choice without any restriction is going to be 34650. 34650 as well as 0. That is what the answer should be. So we have solved number B as well, A and B as well, and both of them are two simplest of all problems. Let's see what question number C says. Question number C says, it says, in how many different ways can teams be chosen if each team must contain at least one man and at least one woman? Okay, so we will have to write team 1. There are 3 teams. Suppose team 1, then team 2, as well as team 3. Okay, so for the first team they have told at least one man and at least one woman. So maximum how many men can we take? We can take 3 men and 1 woman, because total we should have 4. Remember, in every team there will be total 4. So 3 men and 1 woman. For the second team we can choose 3 men and again 1 woman. 3 men and 1 woman. For the third team there remains 3 plus 3 went away, so there remains only 1 man and 2 went away, then 3 remains there, 1 man and 3 women. Okay, this is the first possibility. And the second way we can write, suppose 3 men and one woman again, one woman. And for the second team, we can choose four women, two women, two men, sorry, two men and again two women. And for the third team, we can choose there remains 3 to 5 went away, so there remains two men and one, sorry, two women. Two men and two women are left. Okay, so we can write here for the first case. Look at this. Out of 7, there were 3. If we write here number of selections, let us write number of selections equal to. Okay, so for the first team, look at this. First, there were 7 men. Out of 7, we have chosen 3, and out of 5, we have chosen 1. 5 chose 1. Then remember, here you cannot use the addition symbol because all the teams have been chosen simultaneously together. This is and, not or. So please don't get confused that either first team or second team or third team. It's not like that. Simultaneously, all the teams, all the people are selecting in 3 different groups. That's why it will be multiplication in between the number of selections of group. Okay, then there remains 3 out of 3 has gone, 3 have gone away from main. There remains 4. So 4 choose, we have chosen 3, and there is one women. Out of 4, we have chosen 1. 4 choose 1. We have chosen 4 choose 3 as well as 4 choose 1. Then for the third team, what are remaining? Actually, all of them should be chosen. Look, this is for the first team, this is for the first team, this is for the second team, and we are going to for the third team, for the third team it is multiplication, and this multiplication should be so how many men are left? 3 3 6. 6 have already gone away. There remains only 1 to be chosen, so 1 choose 1. And how many women are left? 1 1 2 have gone away, so there remains 3. Out of 3, we will have to choose 3. This is for the third team. And look at this one very important concept is hidden here. Look at this. If we select the team in this way, so there is another possibility, which is, look, this team 1 can be selected in this way, and 2 can be selected in this way. Okay, and second team can go to the third position. So actually there are 6 different ways, 3 factorial ways. Among these 3 factorial ways, look at this, these 2 teams are exactly same. 3 men 1 women, 3 men 1 woman, first and second one. So it will be 3 factorial over 2 factorial. 2 are identical. That means 6 over 2 means 3 different ways. So look at this, these 3 different ways they can interchange their position. Well, for the next selections, 3 men 1 woman, it is exactly same, plus, okay, plus 7 choose 3, we are choosing 3. Then from 5, it is exactly same, we are choosing 1, into, for the second team, out of 4, we are choosing 2. 4 choose 2. And for women also, there remains 4, we are choosing 2. For the third team, there remains only 2 men and 3 women. Okay, so out of 2, we are choosing 2, and out of 3, we are choosing all 3 women, all 3 women. And as usual, we will have to multiply by 3 because 3 different ways they can multiply, they can interchange their position. This is not permutation. Simply we are thinking that first team can go to the final stage, And or if you think that this is permutation, that is also all right. Look at this, look at this, this team and these teams are identical, two men, two women, two men, two women. So if there are three factorial ways, they can be, this three team can interchange their position, but two are identical. So it is actually 3 factorial means 6, 6 factorials 2 means 6 over 2 means 3. So three different ways actually they can interchange their position. Okay, so let me calculate this. If we calculate for the first one, okay, let me erase some unnecessary parts. So for the first case, it is going to be, let us write equal to, let me write just over here, equal to. So here numerator, in the first case numerator is 7 5 4 4 3. So 7 5 7 choose 3, so 7 factorial. First one is 7 factorial into, look at this, 5 choose 1 is actually 5. So we don't need to elaborate this. Then 4 choose 3 is also 4. Okay. Then 4 choose 1 is also 4. Then 1 choose 1 is 1 and 3 choose 1 is 3. Then finally there remains 3. The numerator 7 choose 3, so it is 3 factorial into 4 factorial. First case. Then all of the rest of them doesn't have any denominator. And finally we will get, our result is going to be, so this is the way. Then plus second case, second 7 choose 3, so 7 factorial into 5 choose 1 is actually 5, so let it remain unchanged. Then 4 choose 2, so 4 factorial over 2 factorial into 4 choose 2 again 4 factorial. Then 2 choose 2 is 1, 3 choose 3 is also 1, and last of all there is 3. Then denominator is going to be, say, 3 factorial as well as 4 factorial, 4 factorial. Okay, 4 choose 2, it is 2 factorial into 2 factorial, 2 factorial into 2 factorial, one case. And another case also there is 2 factorial into 2 factorial, again 2 factorial into 2 factorial, 2 factorial into 2 factorial, 2 factorial into 2 factorial. And for a final team, actually 2 choose 2 is 1, 3 choose 3 is also 1, so that is unnecessary to be written. So finally it is going to be, if we use our calculator, 7 factorial into 5 into 4 factorial into 4 factorial into 3, 7 factorial into 5 into 4 factorial, is it 4 factorial, let me see. So first result is 8400. First one is 8400. Then for the second one, if we use 7 factorial into 5 into 4 factorial into 4 factorial into 3 over 3 factorial into 4 factorial, there are 4 2 factorials equal to, it is going to be 18900. 18900. So finally our number of selection is going to be, let me write just over here, okay, over here. So number of selections total, it is going to be, if we add up 18 18 26 943, so 27,300, 27,000, sorry, 300, isn't it? 27,300 is the number of total selections. There is a twist in this and I tried to clarify every twist. Remember, please don't ignore these permutation last of all, because these three teams can interchange their position. Okay, in that case it will be 3 factorial, but in every case the two teams are identical. Sorry, not this one. For the first case, first and second team are identical. For the second case, second and third teams are identical. That's why 3 factorial has been divided by 2 factorial. Now let's solve the final one. The final question says, the 7 men stand in a line for photograph. 2 of them are brothers, George and Harry. how many different arrangements are there of the seven men, in which there are exactly two men between George and Harry, and this is arrangement. So definitely we will apply the concept of permutation. So George and Harry should not be calculated. Rest seven, there remains five. One, two, three, four, five. Okay. So number of selections, we can write number of arrangements. Sorry, number of arrangements equal to. So there remains remaining men were five. So it is five factorial. Okay, five factorial. Then what is the left place for George and Harry? Exactly two men, seven men, in which there are exactly two men between George and Harry. So let it be G, then Harry. Okay, there will be one more place. So now let's see, one, two, three, four, five, six, and seven. One, two, three, four, five, six, seven. Okay, among these seven, these five people can interchange their position. Okay, so 5 factorial. Again, George and Harry, they can also interchange their position. Okay, they can interchange their position in 2 factorial ways. So there will be two ways or 2 factorial, whatever you tell. Then, then what are the possible cases? These, that if we suppose George and Harry in a box, this is a unit. So how many places? They are already placed one place, then two places, three places, as well as they can interchange their position, not 4 factorial ways. Remember, already they have been arranged. The inner ones, inner people have already, rest of the people have been arranged. So you cannot change, you cannot tell that again they will arrange. There all the arrangements has been done. Now only their position can be interchanged. So one, two, three, four, four different ways, not 4 factorial. Please don't get confused. And if we calculate 5 factorial means 120, 128 are 960. So total there will be 960 ways. And finally, please don't get confused that you will use 4 factorial ways, not 4 factorial ways, because it is George and Harry, including two other boys, all of them have been arranged, but their position can be changed in 4 ways, not 4 factorial ways. So that's all about our permutation and combination topic, and I tried my level best to explain every tiny part lying in every solution. So please don't get confused, and let's meet each other, or let's discuss the other topics. Our next topic is normal distribution. And for solving the first question based on normal distribution, we have chosen paper 9709/51 for the session May June 25. And we are going to solve the very first question, which says the masses of bags of rice made by a company are normally distributed with mean mu kg and standard deviation 0.14 kg. The probability that the mass of randomly chosen bag of this rice is less than 1.48 kg is 0.22. Find the value of mu. So mean value is missing, and we can start writing our solution. Let us write x belongs to normal distribution. You know, normal distribution is applicable only for continuous random variable, and the parameters for every normal distribution is mean as well as variance. So mean is mu given here, so let us write mu, and variance is the square of standard deviation. Standard deviation is given here 0.14, so it is simply 0.14 squared. Okay, not 142, it is 14 square. Then the question has provided that probability of the mass of bags which is less than 1.48 kg. Okay, 1.48 kg is the probability is 0.22. Then we will standardize this z-score. Let us standardize this score. It is going to be probability of z less than 1.48 minus mu over standard deviation. Standard deviation is 0.14 and right side is probability, which is 0.22. Now we will analyze the question. If we analyze the question, we will see our probability is the tiny part in the normal graph. Okay, so probability of z, then first of all we'll have to determine the side or direction of z score. Through a graph, if I draw a normal curve is always symmetrical. Then let us shade our probability. Probability is 0.22 and it is lying on the left side of z score. So it will be on the left side and very tiny part. Okay, so let it be very tiny part. Let it be over here 0.22. This portion is 0.22. 0.22. Well, if this dark shaded part is 0.22, surely the rest of the part is going to be 0.78. 0.78. That means this portion is the probability, or this region is 0.78, because we know that total probability is 1. So probability of this blue shaded part is surely 0.78. Okay, now we will decide our direction of z score. Z score has already been decided that this is our z score. Okay, so our z score is here 1.48 minus mu over 0.14. So what does it means? It is lying on the left side. Okay, it is lying on the left side of mean value. If any z score lies on the mean value means this one. This is standard deviation when it is 0. Here our z score is 0. Okay, at this line, midline, the z score is 0. So if any z score lies on the left side, it will be negative. That means we have decided that our z score is negative. Okay, z score is negative, less than negative. Well, then if we calculate this, we have already decided the direction of z score, which is negative. It is lying on the left of mid value or 0, so it is negative. But now we will have to find the corresponding z score when the probability is 0.22. We are going to use our normal distribution table, in which none of the corresponding probability is given less than 0.5. So what we will do, instead of finding the smaller part, that means 0.22, we will look for the corresponding z-score when probability is 0.78. Z-score will remain same, just the difference is in direction, on leftward or rightward. We already know that our probability is lying on the leftward, so it doesn't make any difference whether we find the corresponding probability of greater part or smaller part. As the graph shows us, all the values are more than 0.5. If you see over here, look at this here, the minimum value given in the table is 0.5, so it is more than half. Always we will look for the greater part, and so we will find the greater part of our probability is 7.78. And for 0.78, if we see the probability 0.78, this one is close to 0.78, that means 7794. if 6 is added to 7794, it is going to be 0.78. That means our corresponding z score is row is zero point 0.7, first column is 7, and final column is 2. So our corresponding z score is going to be 0.772. So this is how we will find the z score. If we don't find exact probability we require, then we will add up the third column. Okay, hence we have got that 0.7794 plus 6 actually 0.7800. So this is our corresponding z score 0.77 and 2. So let it be written 0.772. It is going to be 0.772. 0.772. And I think you have understood why have we used this negative symbol, because z score is lying on the left side of mean line. If any z score lies on the left side of 0, that is negative. That's why we have used negative. And here point instead of 0.22 we have found the corresponding z score of the probability 0.78. If you say that here we will write 0.78, actually 0.78 is lying on the right side. Okay, as we didn't make any change to the direction, it is still left hand side. Look at less than z score, so it is lying left side. That's why left side is 0.22. That's why you cannot make change to 0.78. 0.22 will remain unchanged. If you want to write 0.78, in that case your direction will be different. So we are not changing the probability, it is 0.22, as the z score corresponding z score for 0.22 and 0.78 are same, just the changes in direction which we have used as negative, because this is lying on the left side, our z score is lying on the left side, that's why it is negative. Now both of them are z score. Look at this one is z score, this one is also z score, so surely they are equal. Let us equate the z score. It is going to be 1.48 minus mu over 0.14. 0.14 is equal to negative 0.772. Well, then we will apply the cross multiplication process, and it is going to be 1.48 minus mu is equal to negative 0.772 into 0.14, or our mu is going to be if mu is transposed to the other side, it is going to be positive 1.48 plus 0.772 into 0.14. Hence our mu is going to be, if we round it up to three significant figures, it is going to be 1.5 n, 1.59. This is what our mean value is, and that's how we will solve such question. So just a twist in this question is z score is lying on the left side, that's why we have used the negative symbol, and for greater or smaller corresponding probability z score is always same. Okay, just the change occurs in direction, as it is lying on the left side, that's why we have used negative symbol. I think you got my points. Let's move on to the next question from the same paper. We are going to solve question number 4. Let's find question number 4. This is 2, so it may be 4, maybe over here. This is number 5, that means it is 2. This is question number 4 of the same question paper 9709/51 for the session May June 25, which says every Saturday a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation 2.5 minutes. How many competitors would you expect to have times within 1.2 minutes of the mean time? So this is what the question. This question tells us to find the expected value. Expected value means probability into total number of experiment or competitors. So for finding probability, we don't need to find z-score. Z-score is given already by them. That means we will analyze and find out the z-score. So here we won't find z-score from the normal distribution table. Rather, we will find corresponding probability. Let's start our solution. X belongs to normal distribution, and you know the parameters of normal distribution are mean as well as variance. So mean is given here as 32.4, 32.4, and the second parameter is variance, which is square of standard deviation, that is 2.5 squared. Well, then they have told us to find the probability. That means we are going to find the probability of the people who took times within 1.2 minutes of the mean time. Yes, there is a twist over here. Actually 1.2 minutes of the mean time. That means it may be less than 1.2, less by 1.2 from 32.4. That means mean minus 1.2 or mean plus 1.2. So it's a actually range. So we will have to write in this way. It is actually mean. Look at this. They have told 1.2 minutes of the mean time. So 1.2 minutes of the mean is 32.4. So it is going to be 32.4 minus 1.2 minute. Okay, this is the lower value. Then upper value is going to be less than x, less than 30, mean plus 32.4 plus 1.2 minutes. So I think you got my point, that they have told 1.2 minutes of the mean time. Okay, that means it will be either 1.2 minutes less than 32.4 or more than the mean time 32.4 minutes. Now if we standardize this score, it is going to be probability of, how much is it going, if we subtract, it is going to be 31.2. So 31.2 less than x, or it is going to be 33.6. 33.6. Then as usual we will standardize this score. So our z score is going to be probability of 31.2 minus mu. Mu is already given, it is 32.4. 32.4 over standard deviation, as we did in the previous one, over standard deviation, which is standard deviation is 2.5 minutes. So it is 2.5 minutes until our z score is 33.6 minus mean value is 32.4. 32.4 over standard deviation, which is 2.5. Then we are going to use our calculator for the value. It is our lower bound is going to be probability of, if we divide this by 2.5, it is going to be negative, it must be negative, negative 0.48 until it is positive 0.48. 4.8, sorry, no, not 4.8, it is 0.48. 0.48. So it is going to be, now we will have to draw our curve. Suppose this is our curve and this is the normal curve. Normal curve is always symmetrical, you know. Then this is our mean value. Standard deviation is where 0. So they have told our probability is going to be from negative 4.8, negative 0.48, suppose it lies over here, until positive 4.8, positive 48. Okay, so which part is our probability? Our probability is actually this portion is our probability. Okay, we will have to find the probability of this portion. Okay, so this dark shaded part is our area. This region is to be obtained. So this region can be written in another ways. Look at this. It is actually probability of, if we find the, see, sorry, here it is not x anymore. It should be z score. I made a mistake here. We have already standardized, so it is no more x. It is our z score. Okay. Now it is going to be actually z is less than 0.48, from which we will subtract the left part, smaller part, minus probability of z is less than negative 0.48. Well, we will just subtract this lower part, and I can show you what it means actually. If I draw another figure, what we will do is, first of all, we will find the area of this region where the probability is 0.48. I mean, z score is 0.48. After that, we will just subtract this portion. Let me show this one. Here, negative 0.48. If we subtract this portion, this left part, this blue shaded blue, yes, let me shade it with blue ink. So from this whole of this, from 0.48, when z score is 0.48, then we will subtract this tiny bit. So first of all, we will find the probability of whole of this. Okay, then from this we will just subtract this tiny part, blue shaded part, this portion. We will then subtract this blue portion. That's why we have written, when the z score is 0.48, left part of z score, from which we will subtract one more part, which is when z score is negative 0.48. So one after the other, let us find the z score, corresponding probability for this z score. Let me write just below that. Now I would like to show you this blue shaded part in another way. Look at this. Now if you observe the third diagram, in the third graph, look at this. If we want to get this, look at this, these both, in the second and third diagram, both the tiny blue shaded parts are equal, surely equal, because we know that normal distribution graph is always symmetrical. So as we don't have any corresponding probability which is applicable for negative z score, what we do, we actually convert it into positive z score, and from 1, if we subtract this part, look at this part, if this part, red part, is subtracted, then we will easily find the probability of this tiny part of this z score. Okay, I mean probability of this small part. So what we will do, for the tiny part, from 1 we will subtract the left part. So let us write. So for the first part, it is just unchanged. Probability when z score is less than 0.48, probability z is less than 0.48. But for negative z score, we will have to take, for negative z score, we will just subtract from 1, we will subtract the left part when z score is positive. Z score is less than 0.48. I think you have understood the point I tried to clarify. For there is no probability given in the probability distribution table for any corresponding negative z score. So this is how we have converted these negative z score. These negative z-score has been written this way. This portion has been written from 1, from whole of the probability, just we are subtracting the left part, means this red shaded region. This red shaded region is going to be subtracted. Okay, this part is being subtracted from whole of the figure, means from 1 whole probability we are subtracting this, then we are getting this tiny shaded part, because we require this tiny shaded part to be subtracted. Well, then now we are going to find the corresponding probabilities of these z-scores. Our z-score in both cases is 0.48. Okay, so zero point 0.4 is over here, then row is 0 0.4 and column is 8. That means our corresponding probability is going to be 0.6844. This is what our corresponding probability is. So we will have to just insert this in both cases. 0.6844 equal to 0.6844. Then this is going to be minus 1. If we dissolve the symbol sign, it is going to be plus. Again, the z-score is same, so corresponding probability is also 0.6844. If we simplify this, we will get, our result is going to be 0.3688. 0.3688 is our probability. 0.3688 is our probability. But we should not forget that probability is not our final answer to be shown. They have told us to find the expected value. Look at this, how many competitors should you expect to have? So expected value means mean should be obtained. So expected value, the formula for expected value is mean into probability. I mean total number of, not mean, total number of experiment was 600. It was 600 and probability for each person is 0.3688. So we will write x, or expected value, is equal to ex is equal to, expected value is equal to mean, I mean our total number of experiment is 600 and probability for each of this experiment is 0.36. So our expected value is going to be equal to, if we round it up to whole number, it is going to be 221 point something. So you can write either 221 people or 22 people. Let us write 222 people because it is more than 221 people. So our expected value is going to be, if you round it up, remember you should end up the answer in whole number. Okay, you may use approximation symbol. I have used 222 people as whole number. You may use 221 people also, because calculator shows 221 point something. But as this is number of people cannot be, no object can be, a practical object can be in partial portion. So that's why we have approximated the result. The result will be either 221 people and 222 people. So that's all about the solution to this question. And in this question, actually, there has been twist. First twist was that they have told, they directly didn't tell the score. That's why we have added. They have told 1.2 minutes of the mean time. So first we have subtracted from mean. 1.2 has been subtracted from mean and then it has been added to the mean value. After that, for z score, 1 is getting a tiny part. For tiny part, always from 1 we subtract that the larger part. For tiny probability, remember, always we subtract the larger part from 1. From 1, if we subtract the tiny part, I mean greater part, then we get the tiny part. This is how we have solved this. So this concept should not be forgotten. This is very common and important concepts of normal distribution. So that is our answer is this. Let's see one more question under the same concept of normal distribution. The next question has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 7, which says kestrels are birds whose adult wingspans are normally distributed with mean 74.8 centimeter and standard deviation 3.2 centimeters. A random sample of 120 adult kestrels is selected. How many of these 120 adult kestrels would you expect to have wingspan between 72.4 centimeter and 76.3 centimeter? So it is exactly as same as the previous one. First of all, we'll have to find the probability. Before we write probability, we'll have to write the parameters. So x belongs to normal distribution and the parameters are mean. Mean is 74.8. So 74.8 is mean, and variance is square of standard deviation, that is 3.2 square. So this is our parameter. Now we will have to find the probability of the birds which are 72 from 72.4 until 76.3 centimeters. Now we will have to standardize this score. You know how to standardize this score. It is 72.4 minus our mean value. Our mean value is how much? 74.8. 74.8 over standard deviation, which is 3.2. Less than x and less than 76.3 minus mean value is 72.4. 72.4 over standard deviation, which is 3.2. Using our calculator, we will find that our z-score is going to be, first one is surely negative, or probability of negative 0.75, negative 0.75 until it is no more x. Frequently I am making same mistake. It is not actually x, it is already we have converted to z-score. So it is z less than 0.46875. So if we round it up to three significant figures, it is going to be 0.469. 0.469. Well, then we will have to draw the graph of this scenario. Look, if we draw a graph, let me draw the first graph, this, and you know the graph is symmetrical along the in the line midline. So our first z-score is negative, so it will be lying on the left side, negative 0.7, negative 0.75, let it be 7, and on the positive side it is 0.469, 0.4, let it be 0.4. So which part is our probability? Actually, this dark part is our probability. This portion is our probability to be obtained. Okay, this is our probability. If you have not forgotten, then you must understand that this graph is exactly as same as the previous one. That means we'll have to find this midpoint, for which what we will do, first of we will find the probability when z-score is 0.469, from which we will subtract the left part. If we subtract left part, this tiny part should be subtracted. So z is less than negative 0.75. We'll just subtract the left part. You can go back to the previous part of this uh, solution, not this solution. In the previous solution you will find that how we calculated this. Actually we will subtract this part, this blue parts, this part is to be subtracted. Okay, and how to subtract this blue part, that has also been clarified. So first of all we will find whole of this probability of when the z-score is 0.48. So let us write probability when Z score is 0.469, 0.469, and for this tiny blue shaded part, what we do, we just subtract from 1. We subtract from 1 as we did in the previous case. I think you remember this. 1 from 1 we will subtract the large part. For tiny part always we subtract the large part. Large part will be less than zero point 0.5, 0.75. And if I draw another figure, we require this tiny part. Okay, for tiny part, this tiny blue shaded part is required. Okay, let me change the ink. The color is this. Yes, we'll subtract this tiny blue shaded part. So for this tiny blue part, what we do, we from whole of the probability we subtract the larger part. When probability when z-score is 0.7, 0.7, then we subtract from 1, we subtract this probability exactly like this to get this tiny part of blue shaded part. So this part and this blue shaded part must be equal. Well, it is as exact as the previous one. So for this tiny blue shaded part, what will we do? We will just from 1 we will subtract. Here it has been written from 1 we will subtract the larger part. Then we will get the tiny part. So it is going to be first probability. Let us find the first probability. Using our normal distribution graph, we will find when z-score is 0.469. 0.469 is our z-score, then we will find the corresponding probability. 0.649. So column is zero point 0.6. This is column, and 4 is this is row. First row is 0 0.6, column is 4, and the second column is 9. So our probability is going to be this one, 0.7389, to which we will add up this 29. Okay, so if we add up this 29 from, sorry, I made a mistake, it is not 0.64, it is 469. So our column is 4.4, sorry, our row is zero point 0.4 and column is 6 and the third column is 9. Okay, hence our corresponding probability is going to be here 0.6772, to which we'll have to add this 32. So if we add up 32 to 72, it is going to be 804. Hence our probability is 0.6804. 0.6804, and the other probability, our other z-score was, first z-score is 0.6 804. If you add up, that means total probability is this. Then for the second z score, it was 0.75. Let us see where 0.75, row is zero point 0.7 and 5 is, column is 5. So this one, which is 0.7734. So we have got both of our probability, corresponding probability. First one is 0.6804, second one is it was the column was zero point 0.7 was row and column was 5. Okay, so 0.6804 and another one is 0.7734. Let us substitute this value. First one was 0.6804, 0.6804. I think I can write over here. Okay, minus 1 plus second probability is, let me zoom it out. So these are the values. First probability is 0.6804, then minus 1 plus 0.7734. If we simplify this, our result is going to be 0.4538. 0.4538 is our probability. But it is not the end of the solution, because they have told us to find the expected value, and you know how to find expected value is multiplied by the total number of birds. Total there were 120, so 120 into our probability is 0.45. Again I'll have to zoom it out. Our expected value is ex equal to total number of birds is 120, which should be multiplied by each individual probability, which is 0.4538. And finally, our number of birds, expected number of birds is going to be, if you multiply this, you will find 54 point some. So if we round it up to whole number, it may be 55 birds. You can write 54 birds also. 55 birds is the expected value. Okay, that is what our answer is. You may write it 54 birds, but it must be expressed in whole number. So as this solution is exactly similar to the previous one, I think you have understood better. Then question number B, immediate next question says the masses of adult kestrels are normally distributed with mean mu kg and standard deviation sigma kg. It is known that 20% of adult kestrels have mass greater than 0.202 kg and 28% have mass less than 0.185 kg. Find the value of mu and the value of sigma. Both the parameters are missing here, so the solution will be a little bit lengthier. Okay, so let us start our solution. X belongs to normal distribution, and our parameters are here mu as well as standard deviation is sigma. So mu and variance is sigma squared. Okay, so first probability is given when x is greater than 0.202 kg, 0.202 kg, then probability is 20%. So 0.20 is the probability. Probability is given. We will have to find the corresponding z-score. Okay, so if we standardize this score, it is going to be z greater than 0.202202 minus mu, because mean value is missing, minus mu over standard deviation, which is sigma. Okay, equal to 0.20. Well, then we will have to analyze where z-score lies, whether it lies on the left side or right side. Through the graph, we can explain this. If I show through a diagram, look at this. This is the graph. So here our probability is very tiny part. Look at this. It's 0.20 and right side of z-score. Okay, so 0.20, it's very tiny part. That means this dark shaded part is our probability. Okay, and our z-score is surely positive. Here is our z-score. So the probability of this region is 0.2. 0.20. So surely rest of the part, this part is 0.80. It will be 0.80. 0. Well, this portion, the area or probability of this region, red region, must be 0.80. And you know that whenever we find the probability, always we find the larger part. Okay, because none of the corresponding probability is less than zero point 0.5. Okay, so whenever we use the probability distribution table, we will find the corresponding z-score when probability is zero point 0.8. It is similar to the very first solution. Well, then, and the direction or location of z-score is, look at this, it is lying on the right side. So it is, let me show you, it is zero point 0.2 minus mu. Here is 0.2 minus mu over standard deviation. So as it is lying on the right side of 0, so surely this is positive. So our z score is lying on the right side, so it will be positive. Z greater than, then we will find the corresponding z score for this probability, and probability is 0.20. As we don't have any probability less than 0.5, look at this, the first probability, smallest probability start with 0.5. So we will have to find the greater probability, but z score has already been decided, it is positive. Actually, left and right is required for the symbol of z score. Z score has already been decided that it is lying on the right side, so it's positive. Now let us find when the probability is 0.8. So we are searching for a probability which is 0.8. It may not be found exactly, but we will try to look we will try to find the closest one. Look here, 0.7995, that is 7,995. We require 8,000. So our row is zero point 0.8 and first column is 4. Now as we require 0.8, I mean one more 5 is required to be added. So this is 5. Then exactly it is going to be 0.8. So our answer is 0.84 and the second column is 2. So our answer is 0.842. Look at this. Again, I am explaining that for finding corresponding z-score, first of all, they have told us to find the probability, means we are searching for the probability zero point 0.8. So 0.8 may not be given exactly. We can make it up. First, we have found 0.7995 and we have added 5 to that. Then it has become 0.8. So our corresponding z-score is 0.8, row is 8, first column is 4, second column is 2. So 0.842, and already we have decided that it is lying on the right side. So there is no necessity of negative symbol. It is going to be 0.842. Point 842 when the probability is the tiny part 0.20. Well, then look at this, both of these are z score. This is z score and this is also z score, so they must be equal to each other and we can form an equation. And remember, don't write 0.80 in probability is the tiny part. We are such, if you write 0.80, then you will have to change the symbol z less than. As we didn't change the symbol direction, so you should not change the probability. Total probability is 0.20 when z score is 0.842. That means probability is lying on the right side. If we use left side, then you will have to use negative symbol. Remember, don't get confused. Some teachers may tell that use z less than 0.842. In that case, you will have to change the probability also. As we didn't make change any of these two quantities, so it will remain same. Well, so if we form an equation, it is going to be or 0.202 minus mu over standard deviation is equal to the second z score, I mean exact Digital score is 0.842. Then we can isolate sigma. If we isolate sigma, it is going to be, hence our sigma is going to be 0.202 minus mu over 0.842, 0.842. So this is one of the equation we can write. Equation number 1. There will be two equations because simultaneously two values are missing. Okay, one more equation will be formed. Now let's concentrate on the second part. In the second part, it has been written that 28% 28% of the birds have mass wings have mass less than 0.185 kg. So let us analyze this. Probability of x less than x less than 0.185 is equal to probability is given 0.28. 28% means 0.28. Now if we standardize this score, it is going to be z is less than 0.185 minus means mu over standard deviation is equal to 0.28. If we observe the graph, look at this. Suppose again our probability is tiny part. Look at this. It is just a very tiny part. It may be, and it is lying on the left side because less than z score. So our z score may be over here, which is 0.18 minus mu over standard deviation. Okay, and our probability is, required part is this is our probability. Okay, and this portion is 0.28. If it is 0.28, so the tiny part which is lying on the other side, red shaded part, this must be 72.72. Okay, 0.72. Let us write here 0.72, 0.7 as well as 2. So we know that always we find the corresponding z score of the larger portion. Okay, so for larger portion, yes, and we have already decided that our probability is this tiny black shaded part which is lying on the mean value. Look at this, mean value is here, it is 0 over here. As our z score is lying on the left side, so it must be negative. So we will have to write probability, our z score is negative, and corresponding z score for the probability, when probability is 0.72, we will find the corresponding z score. Our probability is now 0.72. Okay, so for 0.72, look at this, 0.7271 is here. Yes, 7190. There is 7190, and our column is our row is 5, and first column is 8. As this is 90, we require 10. We can add up this. So our corresponding z score is 0.583. 0.583. This is our corresponding z score when probability is 0.7190 plus 10 means if we add up it will be 72. So our corresponding z score is 0.583. Okay, let it be written 0.583, 0.583 0.583, and already we have decided it is lying on the left side of the curve, so it will be negative 0.28. Don't make any change to the probability because we have already seen that it is lying on the left side and we didn't change the direction. It is lying on the left side of the z-score, so it will be as same as this. Now both of these, if we look carefully, this is z-score, okay, this is z-score and this one is also z-score, so surely they are equal to each other, or 0.185 minus mu over standard deviation is equal to negative 0.583. If we isolate our sigma, then it is going to be finally 0.185 minus mu over, yes, we'll have to interchange the symbol. It is going to be negative and it will be positive, so 0.583 over 0.583. It is equation number 2. We have formed two simultaneous equations. Solving the equation simultaneously, we will get that both of them are sigma actually, so minus 0.185, sorry, not minus, or plus mu over 0.583 is equal to, in equation number 1 it was, let's see equation number 1 from the previous page, it was 0.202 minus mu over 0.842. So let it be inserted, equal to 0.202 minus mu, 0.202 minus mu over 0.842. 0.842. Now if we do cross multiplication, we will find that 0.84 mu is equal to 0.84 mu, then minus, if we multiply 0.842 by 0.185, it will be, so it is 0.15577 and 7 equal to, on the other side it is going to be, if we multiply 0.202 into 0.583, it is going to be equal to 0.11776, 0.11, here we skipped 1 2, it will be 0.842, and this is not 0.842 mu, it is going to be 0.583 mu, negative 0.583 mu. So if we add up all the mu's, it is going to be 0.842 mu plus 0.583 mu, it is going to be 1.425 mu. 1.425 mu is equal to, if we add up the other quantities, it is going to be 0.2735, 0.273538. 3838. Hence our mu is going to be, if we divide it by 1.425, it is going to be, if we round it up to three significant figures, it will be 0.192. 0.192. Okay, this is the value of our mu. Then we will find the value of our sigma. Okay, then sigma is equal to, any of the equations can be picked up. Let us pick up this one, 0.02, 0.20, sigma is equal to 0.202, 0.202 minus our mean value was 0.191. 0.191. I am taking more digits than necessary so that the result may be the most accurate one. 0.191 955 over 0.842, 0.842. Hence our sigma or standard deviation is going to be, hence our sigma is going to be, sigma is going to be 0.119, 0.119 if we round it up to three significant figures. Okay, this is the approximated value. So this is how we will solve this question. Let me show the previous page. It was the lower part of this page contains the previous part of the solution, and final part of the solution lies over here. And there is no twist or difficulty in this question, but it is lengthier because simultaneously you will have to find two different values, and from the probability distribution table, normal probability distribution table, we didn't find the probability, rather we found the corresponding z-score. Using calculator also you can do this, but I feel comfort solving and applying this value extracting from normal distribution table. This booklet will be provided to you in the exam. Well, let's see the next question. So we have selected the next question from paper 9709/53 for the session May June 25, and we are going to solve question number 2. At a large college, all students who study science also study exactly one of art or drama or music. 20% of the students study art, 45% study drama, and 35% study music. Three students are selected at random from the students who study science. Find the probability that at least one of the students studies drama. Okay. Sorry, we have chosen a wrong question. Paper is correct. It should be actually question number 6, not question number 2. So paper is correct. This is the paper 9709/53 for the session May June 25, but question number will be 6 actually. So let us see question number 6. This is 5, then it is over here, not even over here. Okay, this is our question to be solved. So from paper 53 of May June 25 session, question number 6 should be solved. A company sells bags of pasta. The masses of large bags of pasta are normally distributed with mean 2.50 kg and standard deviation 0.12 kg. Find the probability that mass of pasta in a randomly chosen large bag is less than 2.65 kg. Very simple question. Let us solve it. X belongs to normal distribution, and our parameters are here. Mean is 2.5 and variance is 0.12 square. So 2.50 is mean, and our variance is square of standard deviation 1 2 square. Okay, and we are going to find the probability when a bag is less than 0.265. So less than 2.65, 2.65, and we are going to standardize this score. If we standardize this score, it is going to be z less than 2.65 chosen bag minus our mean value. Mean value is 2.50, 2.50 over standard deviation, which is 0.12. Then using our calculator, we will find that our z score is less than 0.125, 125. And if we draw a graph, it is very simple. Our z-score is lying on the right side because this is positive, and they have told to find the probability of the left part. So this is our probability. Okay, this probability should be obtained, and our z-score is zero point 0.1. Here it is 0.1, 1.2 or 1.25. Then using our normal distribution table, we will find our corresponding probability when z-score is 1.25. Our normal distribution table is over here, and then our z-score is 1.25. 1.25. 1.25 is a little bit lower. Yes. So 1.2 first. It is 1.2. Then 5 row is 1.2 and column is fifth column. So it is 8944. Simply we can write 894 if we round it up to three significant figures. So it is 894 equal to our probability is 0.894. So the immediate next question says a restaurant manager buys 160 of these large bags of pasta. Find the number of bags for which you would expect. Again, expected value. Expect the mass of pasta to be more than 1.65 standard deviation above the mean. Yes, there is a twist over here. So let us start the solution. Expected value, that's why we'll have to find first the probability. Then it is under the same normal distribution, so there is no necessity of writing the parameters. Let us start. Probability of x is greater than. Okay, it is written that more than more than more than 1.65, more than 1.65 of standard deviation. That means standard deviation above the mean. As it is above the mean, so we will have to add up, and our mean is 2.5. We know. Let us see. Mean was 2.5 kg. So surely it will be added to 2.50. So above mean means we will have to add up 2.5, and we will have to add up this 1.65 of the standard deviation. So 1.65 of standard deviation. How much is the standard deviation? Standard deviation was 0.12. 0.12. So this is how it should be written. So please don't get confused. Once again, I'm repeating that they have told above the mean, so you will have to add up to the mean. Okay, mean is 2.5, and how much is to be added? It will be 1.65 standard deviation. That means 1.65 of standard deviation. So let us solve this. If we standardize this z score, it is going to be z is greater than, after calculation we will get 2.698. 2.698 minus mu. Mu is given, which is 2.50. 2.50, and our standard deviation is 0.12. 0.12. So our z score is going to be, probability of z score, if we use our calculator, it is 1.65. Surely it is lying on the right side. If you draw a curve, look at this. In this one, our z score is lying on the right side of mean value, means 1.65, and our probability is right side. Look at this. So this tiny part. Okay. So for this tiny part, of what we always do, we will just subtract the left part. Okay, if we subtract the left part from whole of the probability, we will get always the smaller part. Okay, so for smaller part, always we subtract the left part, because none of the probability given in the probability distribution table is less than 0.5. So what we will do, we will just subtract the left part. Probability of z less than 1.65. Now we will find the corresponding probability when our z score is 1.65. So our z score is 1.6. This is 1.6 row and column is fifth column. So it is 9.9505. Okay. 1.6 and 5 is our z score. So corresponding probability is 0.9505. So let us write 1 minus equal to 1 minus 0.9505. Hence our probability, individual probability, is going to be 0.0495. 0.495. They have told us to find actually expected value, and you know how to find expected value. Just will multiply the total number of experiment, total number of bags were how many? 160. 160 bags have been taken. So it is 160 into individual probability of each of bags, 0.0495. So our expected value is going to be, if we multiply 160 by 0.0495, it will show more than 7 bags. So you can write 7 bags. If we round it up to whole number, then you can write 7 bags or 8 bags. Okay, 7 bags. So this is what the answer to this part. Let's see the next part. Question number C is, the masses of small bags of pasta sold by the company are normally distributed with mean mu kg and standard deviation sigma kg. Tests show that 77% of these bags have masses greater than 1.26 kg and 44% have masses less than 1.35 kg. Well, so this is a different normal distribution. So we will have to write the parameters again. X belongs to normal distribution where the parameters are mu and standard mu and variance. So standard deviation square, that means sigma square. Sigma square. Well, it is similar to the second solution of this topic. So there will be two simultaneous equations for two different cases. First one is probability of x is more than 1.26. X is more than 1.26. Probability is when the mass is more than 1.26 kg. Probability is 0.77. If we standardize this score, it is going to be z is greater than 1.26 minus mu over standard deviation, which is sigma, equal to 0.77. Now we will have to determine the symbol of z, whether this is positive or negative. Okay, if we draw a graph of normal distribution of this scenario, we will see that, look at this, our probability is more than 0.5. Okay, so for more than 0.5 it will be, but right side of z score, suppose z score is over here, it is 1 point, suppose 1.2 minus mu over sigma, and right side is our probability. This is our probability. That means one thing is very sure, that if we want to get a probability more than zero point 0.5, which lies on the right side of the z score, it, that proves that the z-score is lying on the left side of the main line. That means left side of 0. So it is sure that our probability z-score is negative. So let us write negative. Now for probability of 0.77, we will have to find the corresponding z-score. So let us go back to the probability table. Our probability is 0.77. So if we see, it is 0.776, closer to 76. Yes, this one is 0.7673. So 27 more is required. Let us see, at least we can find 26, we can find 27, sorry, not 26, we require 27. So we got the exact figure for sorry, for 0.77. Our column is zero point 0.7 and first our row is 0 0.7, first column is 3 and final column is 9. Okay, so it is 0.73 and 9. 0.739 is our corresponding z-score when probability is 0.77. So let us write, it is 0.739 and already we have decided that it is lying on the left side, so the direction is negative, I mean symbol is negative. 0.739, 0.739. Then both of these are z-score. This one is z-score as well as this one is also z-score. So they must be equal if we compare. Or 1.26 minus mu over sigma is equal to negative 0.739. Then if we isolate sigma as the subject, then sigma is going to be, dissolving the symbol, it is going to be mu minus 1.26 over 0.739. We may leave this is equation number 1, and we know there will be two different equations because there are two values missing. We will have to obtain them simultaneously. Okay, so the next part says when x is 44% have mass less than 1.35. So less than 1.35. Let me change the color of the ink. X less than 1.35. Okay, it is 1.35, while probability is 44% means 0.44. Well, so let us standardize this score. If we standardize this score, it is going to be probability of z less than 1.35 minus mu over standard deviation is equal to 0.44. Then we will find out the symbol of z-score. Look at this. This is the graph. For this graph, our probability is lying on the left side and it is 0.44. Let's say here our probability is 0.44. 0.44 is our probability, means this part, this small part. Okay, so as this is our probability, hence z score is lying on the left side, isn't it? So our z score is just over here, which is 1.35 minus mu over sigma. And as our z-score is lying on the left side of mean line, so surely it is negative. Our z-score is lying on the left side, so surely it is negative. Okay, so probability z is less than negative. Direction has been found and probability is 0.44. And look, these probabilities also smaller part, so always we find the larger part in the probability distribution table, which will be 0.56. So this portion is 0.56. So let us see what is the corresponding z-score when probability is 0.56. So our probability is 56. For 56, if we see over here, it is 0.5596. With these, if we add up 4, then it will be 0.56. So our column is zero point 0.1. Our row is zero point 0.1 and column is 5 and another column is 1. So it is 0.151 is our corresponding z-score for the probability of 0.56. So 0.151 is our corresponding z-score. 0.151. 0.151 is our corresponding z-score. And now we will have to, both of them are z-score. This one is our z-score as well as this one is also our z-score. So they must be equal. If we equate, hence our z-score is 1.35. 1.35 minus mu. 35 minus mu over sigma is equal to, I think we could have dissolved the symbol, so it is going to be plus and this is minus. Okay, equal to 1.151. 0.151. If we isolate our sigma, then our sigma is going to be, hence our sigma is going to be 1.35. 1.35, sorry, mu plus 1.35 over 0.151, and that is equation number 2. So we are going to solve the equation simultaneously. Let me write just over here. Well, so if we solve the equation simultaneously, it is sigma is equal to mu minus, or you can write here from equation 1 and 2. 1 and then if we do the cross multiplication, it is going to be 0.151 mu 0.151 mu 0.151 mu. I think I can write on a new page because it will take much space. Let me see whether there is no, there is no space over here, but here it is a new page. So our equation is, if we simplify this, it is going to be 0.151 mu minus, if we multiply 0.151 into 1.26, it is going to 0.190 19026 equal to 0.739 mu 739 mu minus, if we multiply 1.35 by 0.739, it will be 0.99765. 0.9976 as well as 5. So if we subtract the mu, it is going to be 0.739 minus 0.151 is going to be 0.588 mu. Negative 0.588 mu is equal to, here if we subtract 0.19026, we will get minus 0.80739, minus 0.80739. Hence our mu is going to be, if we divide 0.80739 by 0.588, it is going to be 1.37311. 1.37311. If we write three significant figures, it is going to be 1.37. 1.37 is the value of mu. Okay, 1.37. Then we applying the value of mu, we can find the sigma, value of sigma. Sigma is equal to, so mu is 1.3731 minus 1.26. If we pick up the first equation, then 0.739. So finally our sigma is going to be 0.153. 0.15 and 3. So these two are the final answer to this question. The value of mu as well as value of sigma. This is similar to the second solution of this topic. Let me show the previous part. This is the present part and the previous part is over here. And I believe that you have understood all these three parts of this question. And before that, it was this. There is one more part. Yes, this one. So this is A. Then there is for B. This is A is over here. This one was A as well as B. Okay. Then C took much space. C is over here as well as over there. So that's all about the solution to the questions of paper 53. Then let's move on to paper 55. The final question has been selected from paper 9709/55 for the session May June 25, and we are solving the question number 2. It says the heights of trees in a certain forest are classified as tall, medium, or small. The heights can be modeled by a normal distribution with mean 20 meters and standard deviation 5 meters. Trees with a height of less than 14 meters are classified as small. For 150 randomly chosen tree from this forest, how many would you expect? So expectation, first of all, we'll have to find the probability. So x belongs to normal distribution, where the mean is 20 and our standard deviation is 5. So variance, second parameter is 5 squared. Okay. Then they have told us to find the probability of classified as small. So small is actually less than 14. So x is less than 14. If we standardize this score, it is going to be z is less than 14 minus mu. Mu is 20 and our standard deviation is 5. Surely it is going to be negative. Our z score is negative because mean is greater than our score. Then probabilities z is less than less than negative. If we divide 6 1.2, it's negative 1.2. So if we observe the graph, in the graph, look at this. Our z score is 1.2 and it is negative. So suppose here there is 1.2 and probability is lying on the left side, means this tiny part is our probability. So for tiny part, always what do? We just find the larger part. Okay, from larger part we will subtract, from whole we will subtract the larger part. That means it is 1 minus probability of z less than 1.2. If I show you another through another figure, it is something like this. We require the small part, this part. So for this small part, here the probability is, I mean z score is 1.2. So here z score is 1.2. Then from whole, if we subtract the left part is, suppose this part is to be subtracted from whole of the probability. Okay, so we will find the corresponding probability when our z score is 1.2. So let us find our corresponding probability when z score is 1.2. So for 1.2, our z score is 1.2. So here there is 1.2. Yes, 1.2. This is 1.2 means 1.20. So row is 1.2, column is 0. That is our corresponding probability is 0.8849. 0.8849 equal to 1 minus 0.8849. Hence our probability is going to be, if we subtract this, it is going to be 0.1151. 0.1151. Now our expected values. Let me change the color. Our expected values is going to be 0.111151 and total number of bag, was it bag or what, trees, total number of trees were 150. So let us multiply by 150. So finally number of trees is going to be 17 trees. Okay, if we round it up to whole number, so there will be 17 trees which will height less than, I mean less than 14 meter, means small. Let's see question number B. B says trees from this forest are classified as tall if their height is at least 8 meter. 25% of trees are classified as tall. So we are still under the same normal distribution. Okay, so let us write probability of x is at least h. So at least h means it is greater than h. Now you may ask that they have told at least. At least means it will be greater than or equal to. Okay, so greater than or equal to is actually greater, because in normal distribution this is continuous, applicable for continuous random variable. So it is actually all the same whether you use equal symbol or not. That means greater part. Okay, is equal to 25%. So probability is given, it is 0.25 tiny probability, or if we standardize, it is z greater than h minus mu over standard deviation. Standard deviation is already given, we have used it as 5, equal to 0.25. Okay, then we will determine the symbol of z score. Let us see Our probability is point 0.5, so point, and it is lying on the right side. So definitely this small part is our normal, I mean probability, small probability. And here our z score is h minus, this is our probability to be obtained, and our this is 0.25, 0.25. So what about the rest of the part? This white part, unshaded part, is going to be 0.75, 0.75. Well, so our z score is lying on the left side, and if we want to decide this as right side, so it is going to be 1 minus, we will have to find probability z is definitely right side, it is positive. Okay, now while finding corresponding z score for probability, always we will find the greater probability. I explained it in elaboration in the previous solutions. So let us find when probability is 0.75, 0.75, and symbol about z score is positive because z score is lying on the right side, which is h minus mu over 5. Okay, z score is this, here it is 0. So let us find the probability when probability is 0.75. Let us see 0.75. So let's see here 7486. So 14 more is required. Yes, this one is 14. So our row is zero point 0.6, column is 7, first column is 7, and another column is 4. So our corresponding z score for 0.75 is actually 6.674. 0.674. So let us write this value. Our z score is 0.674. 0.674. 0.674 when the probability is 0.25. Don't make change this probability because we have chosen, we didn't change the direction of z score. Well, now this is z score. If we compare both of the z score must be equal, or h is equal to h minus mu over 5 is equal to 0.674. By doing cross multiplication, we will find that h minus h is equal to, or h is equal to 5 into, sorry, our mean value was given, mean value was 20. Why are we leaving it unchanged? Let us write 20. Our mean value is already given, so it is 20. Okay, it is 20. So is here it is 20, and then here also it is going to be 20. Okay, it is not mu, it is 20. Okay, so our h is going to be 5 into 0.674 plus 20. Hence our h is, the value of h is going to be 23.4. 23.4 if we round it up to three significant figures. Well, so that's all about the solution to question number B of this question. And with this, I am going to end up this topic. I explained every question as much as possible, and I believe that if you have been attentive, you understood every tiny part of the solution. So let's see the next topic, find out the questions of the next topic. Before we moving into the solutions under conditional probability, let us know what conditional probability is. Conditional probability is actually probability, finding the probability of some experiments under the other conditions. Okay, so there is a probability should be obtained whenever another condition is also applied on this probability. And the fundamental formula for conditional probability is, suppose probability of A given that B, and the formula is probability of A intersection B over, that means probability of A intersection B over probability of only B. So this is the formula for conditional probability, that is A given that B is already there. So probability of A given that B equal to probability of A intersection B over probability of only B. And considering this concept, we will solve the practical problems. So let's get into the first problem we are going to solve under conditional probability. Our present topic is conditional probability, and under this topic we have chosen the first question from paper 9709/51 for the session May June 25. And question number 6 belongs to the mentioned topic. Let's read question number 6. A bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The random variable x denotes the number of blue marbles selected. So x indicates the number of blue marbles, not the number of red marbles. And question number A as well as B don't belong to our mentioned or discussable topics. So let us solve question number C. Question number C says, find the probability that at least 2 of the marbles chosen are blue given that at least 1 red marble and at least 1 blue marble are chosen. So this is a conditional probability. So first of all, we will find that at least 2 blue marbles as well as at least 1 and at least 1 red marble, 1 blue and 1 red marble. What does this mean? It means actually probability of at least 2 blue intersection 1 blue, at least 1 blue, not 1 blue, at least 1 blue and 1 red, 1 blue as well as 1 red. First of all, let us find this probability. So it means actually there should be no less than 2 blue marbles. Okay, so the total number of marbles chosen is 4. So out of 4, it says that there must be 2 marbles blue. So what are the possible cases? If 2 marbles are blue, so 2 blue rest 2 will be red. Or we use addition symbol, or there will be 3 blue marbles and 1 red marbles. I think you got my points. Look, at least there should be at least 2 blue marbles. Okay, so for 2 blue marbles, that means 2 blue marbles, or there can be 3 blue marbles. Well, now from the probability distribution table we solved and prepared in question number B, we can pick up the information. So for 2 blue, the probability of picking up 2 blue is this. Okay, so for probability of 2 blue and 2 red is 3/7. 3/7 plus plus 3 blue marbles. Probability of picking up 3 blue marble is this: 8 over 21 plus 8 over 21. So finally, if we simplify, it is going to be 17 over 21. 17 over 21. Well, then the next part of this solution, then we find the probability of picking up at least one blue and one red. Okay, so let us write probability of at least one blue and one red. One blue and one red. What are the possible cases? If there is one blue, then there will be three red, because total we have selected 4 marbles. So it is one blue and 3 red. Or there will be 2 blue marbles and 2 red marbles. 2 blue and 2 red marbles. Or there may be 3 blue marbles and 1 red marble. So 1 red marbles. Now from the probability distribution table, we can find the probability for 1 blue marble. This is our probability. So let us write 4 over 35. 4 over 35. Then probability of picking 2 blue marble is 3 over 7. So let us write 3 over 7. 3 over 7. Then probability of picking 3 blue marble is 8 over 21. 8 over 21. If we simplify the result, it is going to be 194 over 210. So 194 over 210. 210. Now we are going to write the final step of this solution. These are the actually component of our formula. As I don't have space to write on this page, let's move on to the next page. So what was our probability? It told probability of at least 2 blue marbles, given that this symbol is called, given that at least one red and one blue. This conditional probability is equal to probability of at least 2 blue marble, given that at least one red and one blue. At least one red as well as one blue, over probability of at least one red, one blue. Actually, the formula is, let me tell you the formula on the previous page. Formula of conditional probabilities, suppose it is probability of A given that B equal to probability of A intersection B over probability of individually B. That's why first of all we have found the number probability of intersecting both the quantities. Okay, that means 2 blue marble as well as at least one blue and one red. Okay, then we have found if there is only one blue and one red, for which there are three possibilities. So already we have found both of the components. So first numerator is this 17 over 21 and denominator is 194 over 210. So let us substitute this value over here, equal to, the numerator is at least two blue and intersected by at least one red, one blue was 17 over 21. 17 over 21 divided by 194 over 194 over 210. 210. Now if we simplify using our calculator, it will show 0.876. 0.876. Well, so that's the answer to the first question. Let's see the next question. So the next question has been selected from paper 9709/52 for the session May June 25, and question number 3 belongs to our discussable topic. Question says a bag contains 4 blue marbles and 12 red marbles. One marble is selected at random from the bag. If this marble is blue, it is replaced in the bag. But if it is red, it is not replaced. A second marble is now selected at random from the bag. First question says find the probability that both marbles selected are the same color. So probability of picking up same color is probability of same color. Okay, same color. So what are the possibilities of same color? There may be the first one is blue, second one is also blue. Well, our first one is red, second one is also red, because there were two marbles selected. Okay, what is the possibility of the first blue marble? There were 4 out of 16. 4 out of 16 was blue. Okay, and if it is blue, then it has been kept, replaced in the second bag. Okay, so the number of blue as well as number of total marbles will remain same. That means probability is exactly same. Let's see what happens if first one is red. So for red marble, the probability is 12 out of 16. Now if it is red, remember, if the marble was blue, then what, it was replaced in the second bag. But if it is red, there is no replacement. That means one has been, one from red as well as one from total number has decreased. So it is just 11 and total has become 15. So our probability has become, using our calculator we can write that it's 0.613. 0.613. Let's see the next one. Next question is actually on conditional probability. It says find the probability that first marble is blue given that the second marble is red. Okay, so it is, we know that probability of, what is the formula for probability? Probability of A given that B is equal to probability of A intersection B over probability of B individually. So this is the formula. That's why first we will find the probability that first one is blue intersected by the second one is red. So let us find first blue. Okay, first one is blue. First one is blue intersected by second one is red. Second one is red. Well, now let's see what are the possible cases. First one is for probability of the first one is blue. It is first one is blue and second one is red. There is only one case because there are only two marbles. So if first one is blue, out of 16 there were 4. We can see here First one was blue, second one was red. For first blue, it is 4 over 16. So 4 over 16. I think I can write just beside this. Into second one is red. Second one is red means first one is second one, for second one it is going to be 12 because there were 12 red marbles out of 15. Sorry, out of 16, because if the blue marble is picked up, then it is replaced again. So total number will remain same, but red, there were 12 red marbles, that's why it will remain as it is. So finally we are going to see that our probability is 48 over 256. 48 over 256. Well, then the second component of our probability, that the second one is red. Okay, for second one is red, probability of second red, second one is red. So for being the second one red, there are two possible cases. Equal to, it may be first one is blue, second one is red, or first one is red, second one is also red, isn't it? So if first one is blue, second one is red, it's already we have found the probability is 48 over 256. Or individually if we write, it is 4 over 16 because there were 4 blue marbles, and second one is red as it has been replaced, so total number is same and number of red marble is 12. Or if first one is red, it was 12 over 16, 12 over 16, and remember, whenever a red marble is picked up, then there is no replacement, so both of them has been decreased. 11 over 16, sorry, 15, 11 over 15. So finally our result is going to be, using our calculator, it is going to be 177 over 240. So the probability of a second red is 177 over 240. Now we can write the probability of our question was what? Probability of first marble blue given that second marble red. So let me write over here probability of first blue given that second one is red, equal to, we know the formula is probability of first blue intersection second red over probability of the second one to be red, probability of second one red. So already we have found the probabilities individually. Let us substitute the values. For first one blue intersected by second red, probability is 48 over 256. So we will just write here 48 over 256. 48 over 256 divided by, what is the probability of second red? Probability of second red is 177 over 240. So 177 over 240. Now if we calculate this quantity using our calculator, we will get 0.254. 0.254 is our conditional probability or answer to this question. 2, 5 and 4. So our answer to the question is 0.254. I think you have understood the point. Our fundamental formula is this, that probability of A given that B equal to probability of A intersection B over probability of B. The next question has been selected from paper 9709/53 for the session May 25, and question number 5 is to be solved. It says bag A contains 6 red marbles, 5 blue marbles, and 1 green marble. So total number of marbles is 6, 5, 11, so 12. Bag B contains 5 red marbles and 3 blue marbles. So total number of marbles is 8. A marble is chosen at random from bag A and placed in B. So from A, the marble has been placed in B. A marble is now chosen at random from bag B. Draw a tree diagram to represent this information, giving the probability on each branch. Since question number A doesn't belong to our discussable topic, let's see B. B is on the next page. B says, find the probability that both marbles chosen are same color, not this one even. So question number C is the conditional probability. Find the probability that the marble chosen from bag A is blue, given that the marble chosen from bag B is also blue. So we will write here first probability of first one is blue, bag A. Okay, from bag A it should be blue. Intersection bag B is also blue. So in bag A there were 5 blue marbles. So we will have to write 5/12. Okay. And in bag B, look at this marble has been kept in the second bag B. So the number of marbles in bag B, it will be 9, because 8 plus 1 is equal to 9. And there were again blue marbles, there were 3 blue marbles. Now it will be 4 blue marbles. Let me show you from that page. Look at this here. In bag A there were how many blue marbles? 5 blue marbles. Okay, so we have written 5 out of 12. Total there are 12 marbles. Then if this blue marble is kept in the second bag, then it will be 4 blue marbles out of what? 3 plus 5, 8 plus 1, 9. So out of 9, now number of blue marbles is 4. So that's why we have written 5 out of 12 plus 3 into 3 out of 9, because number of marbles in the second bag will increase, number of blue marble will increase, at the same time number of total marble will also increase. That's why it's 4/9. So using our calculator we will get that it is going to be 20/1, not 20/108, 20/108. Okay, then the next component of our probability is, given that the marble chosen from bag B is blue. So this is only about bag B. So let us write probability of bag B blue. Okay. And for bag B, if it is blue, what about bag A? There is no clear instruction about bag A, so there are the possible cases. If second one is blue, then maybe first one may also be blue. Second one is blue. There may be first one is red, second one is blue, because our condition is about second marble, not about the first marble. And out of two, since there were 2 marbles picked up, so first one may be green and second one is blue. So what are the probabilities? If we write the probabilities, first one blue, second one is also blue, already we have written it is 20 over, means 5/12 into 4/9, plus first one is red. How many red marbles were there? Surely 7 red marbles. So sorry, not 7, it will be 6, because 5 6 1 1 was green, so it will be 6 over 12. Now if second one is blue, second time there were 3 blue marbles. Okay, as one marble has been given, so blue marble will not increase because first one was red, but total number will be increased. Total number was 8, now it is 9. Okay, there was only one green marble, so 1 out of 12 from the first bag, and this marble has been kept in the second bag, so total number is 9. But second one, I mean blue marble, there were 3 blue marbles, still there are 3 blue marbles. So if we use our calculator, it will show that our probability is going to be 41 over 108. 41 over 108. Now we are going to write the final part of the answer, which is probability of the condition. Question is probability of from bag A it should be blue, given that from bag B it is also blue, over equal to, if we apply the formula, it is bag A blue intersection bag B also gives blue marble, over probability of bag B blue. Okay, so the answer should be, already we have found the quantities. The first probability, when bag A, from bag A blue marble is chosen and from bag B also blue marble is chosen, our probability is 20 over 108. So we will write 20 over 108. And if the condition is only the second marble should be blue and there is no question about the first marble, the probability is going to be 41 over 108. So finally, if we divide 20 by 41, it is going to be 0.488. 0.488. So that is what the final answer to this question is. Let's select the next question. The next question belongs to paper 9709/55 for the session May June 25, and we are solving question number 4. Students applying to Drydale College take an entrance test. A student is either accepted or rejected or required to take another test with probabilities 0.3, 0.2 and 0.5 respectively. When a student takes a second test, the outcomes and probabilities are exactly the same as for the first test. A student who has to take a third test is accepted with probability 0.25 or rejected with probability 0.75. Draw a tree diagram to illustrate this information showing all the probabilities. First question belongs to a tree diagram, which doesn't belong to our present topic, but the information may be required for our solution, so we have left it solved here. So let's see question number C. We are going to solve question number C. Question number C says, find the probability that a randomly chosen student who applies to Drydale College takes at least 2 tests, given that the student is accepted. So after second test he was accepted. That means first time he was given a chance to take part in the second test, and second time also he has been given a chance to sit again. Then finally in the third chance he was accepted. So first of all, we will have to write probability of second test was done, and then he was accepted. He was finally accepted. Okay. So if second time he takes the chance, what are the probability? That is, he might be he, what was the cases? First time he must take the second chance. So first chance was given and then he was accepted. Or second time he was, first he was given a chance, again he took the chance, and then he was accepted. So these are the possible cases for a student to be accepted. Okay, the question is at least two tests. Okay, at least two tests. So it should not be second test, it should be at least two tests. So let me rectify this. Yes, this is the actual scenario. That means at least he was given two chances and then he was rejected, accepted. That means it might happen that first time he took a test, then in the second time he was accepted. Because look at this, at least two tests means initially for the first case, I mean first time he was not accepted. Okay, so at least two tests means there he might be given one chance or he might be given two chances. So one chance means actually T. That means for second test. Or if he has accepted all the opportunities, that means first time he failed means he was given a chance to take test again, then he was given again, he was given a chance to take part for the test, and then finally he was accepted. So what are the possible cases? If first one is T and A, from the previous page we can insert the information. Yes, first one is T. For first T it is zero point 0.5, and then if he is accepted it is 0.3. So 0.5 into 0.3. For the second one, first time he was given a chance, again he couldn't qualify, then he was given another chance, then he qualified. So what are the probabilities? For the first case it was T into A. Okay, 0.5 into 0.3. For the second case it is first he was given a chance, 0.5, again he couldn't qualify, so he was given the second chance with 0.5, then finally he was accepted, he qualified with 0.25 as probability. So let us write all of these probabilities. It is going to be for the first one, first T was 0.5, and if he is accepted then it is zero point 0.3 for the second test. Then for the first chance he was given a probability is 0.5, and for the second chance also probability is 0.5, and finally for acceptance the probability was 0.25. Okay, so what is it going to be? If we sum up, it is going to be 0.2125. Well, now second part of the solution, that probability of the student was accepted. Okay, probability of acceptability. So there are three possible cases actually. He might be accepted at the first test, or he failed in the first test and accepted in the second chance, or he might fail in the first test as well as second test, but finally in the third chance he got succeeded. So these are the probabilities. Now we are going to find the probabilities from the tree diagram. If he succeeds in the first test, if the student succeeds in the first test, it is first chance 0.3. Okay, if he takes second opportunity. So for T, for failure, it is 0.5, and then he might be accepted. So it is 0.5 into 0.3. Okay. Again, the third case is first time he was given opportunity. Again, second time also he has to take a chance. Then finally he was accepted. So it is 0.5 into 0.5 into 0.25. So these are the possible cases. First 0.3, then 0.5 into 0.3. So first one was 0.3 for succeeding in the first chance, 0.3. Or he might be given the chance to take part in the second chance, then acceptability is 0.3. Or he failed in the first test as well as second time, but finally he succeeded, whose probability is 0.25. Then after simplification we will get that 0.5125 is the probability. Now we will write the final part of the solution. What is the final part of the solution? That probability of at least two tests given that accepted. So we will write here probability of two tests given that the student is accepted equal to probability of two test intersection accepted over probability of acceptability. And we have already found these components, so we can substitute the values. So let us substitute the values. First probability was this 0.2125, which will be divided by 0.5125 equal to 0.2125 over 0.5125 and using our calculator we can find the answer to this conditional probability is 0.415. 0.415. Well, then the immediate next question, though this doesn't belong to our today's topic, yet let us solve this. The three friends apply to Drydale College. Find the probability that all three are rejected. Since the total number of student or total number of experiment is given, that three friends, so it actually belongs to binomial distribution. In the binomial distribution we didn't solve this, that's why let us solve right now. And the parameters for binomial distribution is x belongs to binomial distribution, and parameters are total numbers is 3 and individual probability. So let us see what is the individual probability for one student, not all three students. So for one student, for being rejection, what may be the possibilities? Let us find this. The probability of rejection, okay, for one student, he might be rejected in the first chance, or he was given second chance, that means T, then he was rejected, or he took the third chance, that means first time he failed, second time he failed, third time he was rejected. So what are the probabilities for first rejection? From the previous page, for first rejection the probability is 0.2. For the second rejection, it will be zero point 0.5 into zero point 0.2. For third rejection, it will be 0.5 into zero point 0.5 into 0.75. So these are the probabilities. Let us substitute this information. If we substitute this information, for first rejection, probability of rejection is for first rejection probability is 0.2. or first chance. For second test, probability is 0.5, and for rejection, probability is 0.2. And if he takes two chances, so 0.5 for first chance, and probability of second chance is also 0.5, then if he is rejected, then probability is 0.75. 0.75. So what will be the probability of a student who may be rejected is equal to, if we use our calculator, it is going to be 0.4875. 0.4875. 4875. Well, so our parameter is, this is our parameter 0.44. Remember, parameter is individual probability of one unit or each experiment. 0.4875. As this is binomial distribution, how to write binomial distribution? Probability of all three. Okay, x equal to 3. That means all three. Probability of x equal to 3 means all three are rejected, is equal to 3 out of 3. 3 choose 3, you know the combination formula. Out of 3, 3 out of 3. 3 out of 3 have been failed, and our probability of rejection is 0.4875. If probability of rejection is 0.4875, that means 3, all 3, and probability of acceptance will be 1 minus this, which is 0.5125. 0.5125, and no one was rejected, I mean accepted. So finally 3 choose 3 is actually 1, and 0.51250 is also 1. That means our probability is 0.4875 3 times. Okay, so finally our probability is going to be equal to 0.116. 0.116. 0.116 is the probability of 3 students being rejected. So that's all about this topic. Let's see the next topic. Our next topic is box and whisker plot. And under this topic, the first question has been selected from paper 9709/53 for the session May 25. And question number 4 belongs to our discussable topic. It says 84 people attempt a particular puzzle. The times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. So graph is provided over here. And question number A says, use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. This doesn't belong to our box and whisker plot. So surely question B belongs to our mentioned topic. Question number B says, on the grid below, draw a box and whisker plot to summarize the information in the cumulative frequency graph. Well, for box and whisker plot, we require 5 information. Remember, for box and whisker plot, we require 5 information. So let us write all those 5 information. What are those? The information we require, the first one is minimum value. Minimum value of the data, minimum. Okay. Then second one is quartile 1. Quartile 1 is required. Then second quartile or median, whatever you tell, let me write median. then median is required. Median. Okay, this is quartile 1. After that, third quartile is required. Third quartile, that means quartile 3. Third quartile or upper quartile. After that, we require the maximum data. Maximum. So for box and whisker plot, we require 5 information, and from the given cumulative frequency graph, we will find these 5 data first of all. Then we will plot the box and whisker. So let us see how much is the minimum, median, and minimum quartile 1, second quartile, third quartile, and maximum. So minimum time taken by the people is 2. This is our minimum. This point is our minimum value, 2 minutes. Okay, then lower quartile. Lower quartile means there are 84 people. So 1/4 of 84 is 21, which is just above this. So our lower quartile is this, and then for median will be 42 people. Let us find 42. It's exactly over there. Then upper quartile, third quartile is going to be 63. So 60, 62, and 63 will fall over there. 63. Then maximum is lying just over here. Maximum is over there. Maximum is already given, so there is no necessity of plotting there. Maximum is given 12 minutes. Okay, this is maximum. Now we will find this coincidental points. So where it coincides from the graph. So we have got all 5 essential points. First one is minimum point is 2. Then lower quartile is 3.8. Then upper quartile is median is 4.8. Then upper quartile is 6.6. Well, then we are going to just write these values. So our minimum is 2. Minimum data is, the minimum value is 2. Then lower quartile is 3.8. 3.8. Median value is 4.8 minute. 4.8 minutes. Then upper quartile is 6.6 minutes. 6.6 minutes. Then maximum value is 12 minutes. 12 minutes. Well, using this, now we are going to plot a box and whisker. So our minimum value is 2. Okay, so let us draw a line over here 2. Then lower quartile is 3.8, which is just over here. Then our median is 4.8. So 4.8 will be just closer to this. Then upper quartile is 6.6, means it is not close to 7. Then maximum is 12. So let us join these. So let us make the box. So this is what our box and whisker plot of the given information. Then let's move on to the next question. The next question belongs to paper 9709/55 for the session May-June 25, and question number 5 belongs to our present topic, that means box and whisker plot. Let's read the question. The smarts and the teasers are 2 quiz teams, and that each contain 11 members. Both complete a puzzle, and the following table gives the times taken in minutes by the members of each team. Represent this information in a back-to-back stem and leaf diagram with smarts on the left hand side. So our this question doesn't belong to our particular topic. So let's see the next question. From the stem and leaf diagram, we can find 5 information, because we know for plotting a box and whisker plot, we require 5 information. So first one is minimum. For smarts, the minimum value is 9 minutes. Then first quartile, there were total how many data were there? There were 11 members. So the second quartile, I mean first quartile will be 11 plus 1 means 12, 1/3 of 12, that means fourth data. So minimum is 9. After that, first quartile. So 1, 1, 2, 3, 4. So this is Q1. Q1. After that, the eighth value will be, sorry, not fourth, it is 3/4 are 12, so it's third data. This is lower quartile. Then our median will be sixth data. 1, 1, 2, it is 3, 4, 5. This is Q1. Q1 lower quartile. Then 4, 5, 6. This is our Q2, I mean median. Then 7, 8, 9. Ninth data is going to be our upper quartile, third quartile. These are for the smarts. Then for teaser, minimum value is 12, and the lower quartile is 1, 2, 3. So third quartile, this is upper lower quartile is 8, not 8, 18. Then for median 3, 4, 5, 6. This is our second quartile or median. Then third quartile is 7, 8, 9. Ninth data is our upper quartile, and maximum value of the smarts is 41, and maximum values for teasers is 39. So we have got all of this information. Let us write the values of smarts. That is, lower quartile is 13, then median is 22, upper quartile is 30, upper quartile is 30, and maximum is 41. So let this be written. So for the smarts, lower quartile is minimum was 9. Minimum was 9 minutes, and lower quartile was 13 minutes. Then median was 22 minutes. 22 minutes. Upper quartile was 30 minutes, and then maximum value for the smarts were 41 minutes. 41 minutes. Now let's see the 5 information for teasers. For teaser, minimum is 12. The first value, this is the minimum value. So 12, 18, 25, 37, and 39 is the maximum value is 39. So let this information be inserted there. Minimum is 12 minutes. It's 12. And lower quartile was 18. Then median time was 25 minutes. 25 minutes. Upper quartile was 37 minutes. And maximum time taken by the teasers is 39 minutes. Now we are going to just draw the box and whisker plot from this. Okay, so our maximum value is 41. That's why So minimum value for the smarts is 9 minutes. So let us mark 9 is just over here. 9. Then lower quartile is 13. 13 is over there. Then 22 is the median. Median time is over here. Then 30 is the upper quartile. 30. Then maximum is 41. So 41. This is for the smarts. And then for the teasers, minimum is 12. So 10, then it will be 12. After that, lower quartile is 18, which will fall over there. Then 25. 25 is the median. 37 is the upper quartile. 37 and 39 is the maximum value over there. So let us make the box and whisker. So this is the box and whisker plot for upper one is for the teasers. Okay, this is for teasers. And lower one is for the smarts. Smarts. So this is how you can make box and whisker plots. Then the next question say make two comparisons between the times for the two teams. So first comparison is if we look at this, the median value of the smarts is less than the teasers. Look, median is how much? For the smarts, median value is 22, whereas the median value of the teasers is 25. So we can say that the smarts are faster, quicker. So number one, the smarts are quicker. And second comparison we can make is if we look at the smarts, look, their values, that means interval in between the boxes or lines are more consistent than the teaser. Look at here, 9, 13, 22, 30 and 41. This is more consistent than the time 12, 18, 25, 37 and 39. That's why the smarts time smarts times are more consistent, consistent consistent. So these may be the two comments. These comments can be made by yourself also. Observing this, you can write in another way also, but I thought that this may be the more appropriate comments on these two box and whisker plots. That's all about the topic, and let's see the next topic.